So good morning, participants present at NIRRR Chandigarh as well as participants at various remote centers. So today we will have this session on GSM and other cellular wireless technologies. In the second session, we will be covering the 4G and LTE networks. And after that, just the completion of second session, we will be having validation and feedback from the participant at 12:45 p.m. So I request the remote center coordinators to be prepared at 12:45 for validation. And please use the feedback form that I have mailed yesterday to all the remote center coordinators. And please make some changes on that form. That form is basically shows the title as cloud computing and dates are different. So you are requested to please change the course title to wireless network, and the dates of course are from 2 to 6th of May. So I request all the remote center coordinators to take feedback from the participants present at your locations. So now we will start with this session on cellular wireless networks. So I hope we have already covered few of the things in this course. I started with the first session of this course on wireless communication basics. Now we will covering the cellular wireless networks. We all are using nowadays mobile phones with us, and figure on this slide shows a typical kind of cellular wireless network. We can say that a cellular network or mobile network is a communication network where the last link is the wireless. The last link wireless signifies that the whole network is not wireless. The complete network from mobile station to base station, from base station to BTS, from BTS to BSCs, BSCs to MSC, whole network is not wireless. Only the last link that is connecting the base stations, or you can say BTS, to the users, that link is basically the wireless. The network is distributed over land areas called cells. The network is divided into a small geographic regions. Those regions are called as the cells, and each cell is served by at least one fixed location transceiver. Transceiver is basically a transmitter receiver. There is at least one transmitter receiver in each cell. We can have more than one also, depending upon the technology we are using. And this region, this small region, is basically known as the cell site or simply the cell. Figure shows that this is a cell. This oval region is showing here. We are having these cells, and here we are having the base stations, or you can say BTS. We have reached up to the, in our country, we have started using the 4G cellular networks. Even the research is going on in case of 5G networks also. But these networks were actually evolved from first generation. In the case of first generation cellular networks, we were using the analog signals. So due to the usage of these analog signals, the quality of communication as well as the data transmission was not possible. Or it was possible, but the speed at which the transmission was possible was very, very less. And due to the usage of analog signal, the errors are also very high. So transmission of data is sent via continuous analog signal, as I said to you, but due to the usage of analog, the transmission speed of data is very, very less, and it takes very, very long time for just searching even a simple website. In case of second generation cellular network, this is one of the cellular network that is most popular in our country. Till date, we have been using this 2.5G. This is just the advancement of 2G. All the users have till date not moved on to the 3G networks. Although 4G has been evolved in our country, but still the people are using the 2G cellular also. So second generation cellular networks refers to digital cellular and PC wireless systems. Voice and low speed data services are possible. So still in our country, we are using the low speed data services. Although in case of 2.5G, we have increased the speed up to some extent, but still it is not up to the mark. So they consist of digital traffic channels, perform encryption, error detection, and correction. So these encryption, error detection, and correction are not possible in case of 1G. That is why error rate was quite high. And in this, users share the channel dynamically. In case of analogs, we were using the static channel allocation. Each channel is allocated to one user, and by that time, they will not free the channel. Another user cannot use this. Dynamic channel allocation is also evolved with the 2G, second generation. 3G is just the advancement of second generation cellular network. In this, we have reached the data transmission rate of up to 2 Mbps basically. The target of third generation cellular network was to go up to data transmission rate of 2 Mbps. This is basically the maximum speed. Although in our third generation mobile technology that we are using, we are not getting the speed up to 2 Mbps. This is the maximum speed. And moreover, this third generation cellular networks, they are working in the range of 2100, I think, megahertz horsepower. In case of second generation, we were using 900 range something. Third generation refer to the next generation of wireless system. This is digital with high speed data transfer, as I said to you. Its voice quality is comparable with the switched telephone network. This is one of the important features, because in case of wired network that we were using earlier in of PSTN basically, so in this third generation is having a voice quality up to that one, and even the data transmission rate is also increased, and we can easily use the internet services. And in this, we have both symmetrical as well as asymmetrical data transmission rates. It provides support for circuit switch as well as packet switch data services. In earlier, we were using only the circuit switch. So if a circuit is formed from end-to-end connection, the all the packets will be following the same path. But in case of packet switch, packets will be sent after following a different path also. In case of 4G, we have further increased the speed. 4G and 5G technology will be covered in the next session by our expert. We will be starting from the this cellular networks, how it works basically. So in case of the cellular networks, we have these fundamental components like a mobile station, that is basically the handset that we are using for this mobile connection. We have one BTS, that is the base transmitter receiver. This is basically the antenna with the transmission receiving facilities placed at the base station, and these are one or two, basically these are one in one cell. It may be possible that we have more than one. Likewise, we have BTS and MTS also. These are the component of MTS, so basically mobile telephone switching offices. And as I said earlier to you, the connection from base station to BTS is basically wireless. All other connections are they are using the wired connection, because they are acting as the backbone network. Generally, fiber optic cables are used for this. You can see here how the cellular network is working. We have public communication switching network. It is still existing even nowadays also. So we want compatibility between our cellular network as well as the existing one. So that is why we are using the mobile telecommunication switching office, that is an interface between these two, the landline network and the base stations, or you can say BTS that we are using. We can see here mobile phone to the BTS, or any user who is sitting in the car is using his mobile phone, and the connection up to the BTS is the using the radio link. So our handset, or simply we can say base station, includes an antenna, a controller, and number of receivers. In my first lecture, I said to you that antenna is one of the important component of any transmit communication system. So I said to you in that day also, there is an inbuilt antenna in our handset nowadays. No external antenna is provided. But whenever we want to use the FM or radio communication, in that case, this internal antenna is insufficient. For that, we need the external antenna. In that case, our earphone lead will act as an antenna. So, mobile telecommunication switching office, in which case, the antenna located at the base stations. These are not omnidirectional. These are directional antennas, and focusing onto the particular cells only. That is why whenever you, this is basically omnidirection because it is transmitting the information. But in case of BTS, it is the directional advice. That is why as soon as you go just the level above than your BTS, your mobile phone will not work. And likewise, whenever you are going to the underground, in that case also it is basically degrades drastically. Mobile telecommunication switching office, they connect the call between the mobile nodes. They are basically acting as the coordinators. They are managing the whole network while utilizing the BTS and this MTS. So two types of channels available with mobile unit and base station. These channels are known as traffic channels and control channels. We have already discussed what is channel basically. It is just a range of frequency given to a particular user for making a call. Suppose one frequency spectrum is allocated, so from that we divide the spectrum into the small frequency ranges that is required for at least making a call. So we have two types of channels, traffic as well as control channels. In case of traffic, we carry the voice and data. These channels are basically utilized by the users for making the call and data transmission. And control channels are used to exchange the information for the setting up of the call and maintaining the calls. Can you tell me why we are using these separate channels? Is it not possible to manage the network with the one type of channels? Why there is a division of these two? My question is why there is a division. Suppose we are having suppose 10 channels. So generally what happens ki out of 10 we are 8 we are reserving for the data and 2 we are reserving for the traffic channels, or you can say control sorry, for 8 for the traffic, right, that includes voice as well as data, and 2 for the control. But why we are making this division? No, you haven't understood my question. My question is why there is a division of, suppose these two channels are reserved only for the control purposes. Can't we dynamically manage out of these 10, two are any two of this can be utilized
So
for control?
control channels must be real time. We cannot afford to lose the data packets of control channel because they are, that is the metadata and it is for management. So it is very important. So we are using a separate channel so that its packet do not collide with other packets.
Yeah, this is the reason, and that is why very correctly said from one of the participants from the remote centers, and that is why the priority of these control channels are higher as compared to the traffic channels. So sometimes when there is a congestion, the traffic channels cannot work. Even in that case, the control channels are working. So these are required when we want to make any call or we want to disconnect any call. Suppose there is suppose system hang-ups, your mobile unit hangs up. In that case, we need the control channels to disconnect the call. That is why they are having the higher priority. Likewise, the public land mobile network refers to a cellular network that has land and radio base stations. We have already covered this. Mobile station, a device used for communication. And BST is basically the base station transmitter receiver. There are some more components like MSCs and BSCs. They also plays a key role in the cellular network. MSC sets up and maintains calls made over the network, and BSCs communication between a group of BSTs and a single MSCs. So BSCs are acting as an interface between the MSCs and the BTS. And PSTN is basically the earlier landing networks than we were using, and nowadays also it is used some of the places. So whenever we are making an outgoing call from a mobile unit, uh, we input the phone number to which I want to make a call and press the send button. So mobile links to the base transceiver via the control channels. So our mobile station will request to the BTS, and that will request the BSCs, and it will go up to the MSCs requesting for the control channel. And control channel will be allocated to initiate the call, and as soon as the call is connected at both the parties, as soon as the receiver picks up the call, this control channel will be free and the traffic channel will be allocated to the both the users. So MTSO routes connection back to the mobile via voice channel, as I said to you, and mobile shifts the control to the voice channels. Whenever there is an incoming call to the mobile, all goes from PSTN to MTSO. This is basically the case when we are making a call from landline to the mobile phone. Call will go from PSTN to the MTSO, that is the mobile telephone switching office, on control channel. MTSO searches for mobile by paging every active mobile. If found, MTSO rings it and establishes the voice connection. In between, it is also utilizing the MSCs and BSCs. And after using that, it will go up to the BTS. So it uses the transceiver with strongest signal from the mobile. That is why whenever there is an incoming call, the signal strength is quite high. You can check this if your mobile is placed near to any of your like television. If there is an incoming call, the disturbance will be quite high. As soon as you picks up the call, the disturbance will go down. This is the difference between the traffic as well as control channels, because control channels are having higher priority as well as higher strength. As soon as the control channel shifts to the traffic channels, the interference will be reduced. So we all know that these cells are generally hexagons and represented, or you can say studied with the help of hexagons. Generally in actual scenario, if we can say, and physically we can see these cells are hexagon in shapes, but exactly physically when we place the BTS, or we can say BSCs, it is not possible to have the hexagonal shapes. First reason is we don't have antenna of such kind which can uh, uh, transmits the signal in such a, in an hexagon shapes. Generally, the signals are strength in a circular or oval direction, we can say. So these hexagons are generally used for study purposes basically, because these are the most similar to the circles. You can also use, like shown here, you can use the triangles, you can use the squares, but the most similar shape with respect to the circles is the hexagon. But in circles we have few drawbacks, but if we do not overlap this area as shown here, then there will be a free space between 2 or 4 cells that will be not covered by any of the BTS. If we overlap these cells, then there will be overlapping of cells that will result in the interference. Generally, we use the cells. We use the hexagons for study, but in practically, it is not possible to have cells of kind hexagons. So cells are low-powered, basically transmitters. Each cell is allocated a band of frequencies and is served by its own antenna, as well as a base station consisting of a transmitter, receiver, and a control unit. And with a combination of multiple cells, it results in a cluster. Combination of certain cells results in a cluster. Like we can see here, we have here a 7-cell cluster, and our channels, suppose we have 70 channels with one cluster. Generally all the channels are allocated to a particular cluster, and cluster is replicated to all the nearby physical areas. Suppose we have 70 channels to one cluster, so those channels will not be allocated in such a way, like suppose channel number 1 to 10 will be allocated to, suppose this cell number 1, channel number 2 to, suppose 11 to 20 will be allocated to cell number 2. It is not like that. If we allocate the channels in such a way, then there will be an interference between the nearby channels. To avoid this, we allocate the channels in such a way, suppose channel number 1 is with cell 1, 2 with 2, 3 with 3, 4 with 4, 5 with 5, 6 with 6, 7 with 7, and then the channel number 8 will be allocated to the cell number 1, and this will go on and on. Now, how many cells we can have in one cluster? This is governed by this equation, that is equals to I square plus ij plus j square. So, and our ij can have the value greater than equals to 1. So we can have either 3 cells in one cluster, 4, 7, 9, 12, 13, 16, 19, 21, and so on. And this is known as the reuse factor basically. It's known as reuse factor. So what happens as soon as we increase the number of cells, or you can say we increase the reuse, the channel capacity, or you can say the system capacity will be increased. Because as soon as we reuse the more number of channels frequently by reducing either the cell size or incorporating the more number of cells in one cluster, our channel capacity basically signifies how many users can be accommodated at a particular instance of time. So channel capacity, or you can say system capacity, will be increased accordingly, but it will result in interference. So for that you need good quality circuitry. You can see here, as I said to you, the top figure, this one on the right side, this shows the fictitious cell pattern this we use for study. Ideal cell pattern with respect to the antenna, it is like these circles, but physically it is not possible to place the antenna with equal distance due to the already existing buildings in the places, because generally we are having these kinds of network like cellular network. We are not going to place cellular network in places those are completely vacant. It is not like this. You will place your BTS on the fields and on the mountains where no person is residing. Generally it is in the already civilized areas, so where we place our BTS, we have certain hindrances with respect to building, so it results in these kinds of cells. So here we have shown here 7-cell reuse pattern. We have 7 cells in one cluster, and this whole cluster is replicated. So whole frequency spectrum that is allocated to this will be replicated here. You can see here the same labels are used here. A cell is replicated at this place. This also shows the same thing. This frequency f is replicated to this place. So mobile unit which is placed at this f and another mobile unit which is placed at in this cell, they can use the same frequency and they can make the count. This again shown the cluster. 3-cell cluster is used here, A, B, and C, and the frequencies applicated. Here we have 4-cell cluster, and here we have 7-cell cluster. And how these clusters are made, we have already shown the equation n is equal to I square plus ij plus j square. But how this will be replicated and which place this frequency will be replicated is governed by this one. You just move I places in one direction and then perpendicular to the this vector you go into the j direction. Like here we can see the value of I is equals to 2 and j is equal to 1. So we will move from one, this one is used here, we will go j step to this one, and in the anti-clockwise direction perpendicular to this one we will go to the upward direction. As a result of that, this one will be replicated here. You can find where a particular frequency, or you can say where a particular cell will be replicated, because it is easier in case of 3-cell or 4-cell or 7-cell, but as soon as your cell size, number of cells in a cluster are increased, it will be difficult to you to find where the frequency or cell is replicated. You can identify with the help of this formula like it is shown here. Here the value of I and j we are having 3 and 2, so we will go 3 steps in one direction and anti-clockwise moving, and then go 2 steps in one direction. This is a 19-cell reuse pattern. So we have 19 cells in one clusters. And this, as I said to you, we decrease the cell size, more cells can be accommodated in the clusters, but it will result in the interference, because co-channel reuse ratio, as I said to you, if we decrease the cell size, then more number of cells can be accommodated in one cluster. So more frequency reuse will be there. We will reusing the same frequency at a nearer distance. So if two mobile units, as I said earlier to you, like in previous, you can see here also, this is one, this is one. It means two mobile units are there. Those are using the same frequency. So if these two mobile units are quite near to each other, it will result in the interference. So our distance between two cells, those are using the same frequency, or you can say the frequency reuse ratio in such a way that there should be no interference. That will be governed by this equation, that is Q, this co-channel reuse ratio should be D upon R, where D is the distance between the two cells, those are using the same frequency band, and R is the radius of each cell. If the radius of cell is large and this D is small, it will result in the co-channel interference. It is governed by this equation, Q is equal to D upon R, or under root 3n, where n is already we have covered, that is found out with the help of I square plus ij is equal to j square. So we have this in cellular network, we have two kinds of interference, co-channel interference and adjacent channel interference. Co-channel interference is resulted from those mobile units, those are using the same frequency. So this interference will not occur in a one cluster, rather it will occur in basically two clusters, two nearby clusters, in which frequency reuse is done. I'm coming on to the adjacent channels, but co-channel interference will occur if you will not take this into consideration. This Q is equal to D upon R. If D is small and R is large, then there will be co-channel interference definitely. You should take this into consideration. Suppose you have only 3 cells cluster, then these two cells will come near to each other, and if you increase the radius of cell, then definitely there will be high co-channel interference. And like you see here in this figure, this is basically the ideal figure. As I said here, this is the ideal figure which we are studying here, but in practical the actual cells are like this. So it may be possible that some person of this cell which is falling at a boundary. Suppose there is one person who is located at the boundary of cell number 4, and there is another person who is at the boundary of cell number 4 in the reverse direction to the upper one. And these diagrams are basically with respect to the ideal cell, but in practical we are not having such kinds of cells. It will result in the co-channel interference. And coming on to the adjacent channel interference, this is the kind of interference that is generated by the two nearby frequency channels. Suppose the frequency band, suppose 566 kilohertz to 576 kilohertz is allocated to one user, and from suppose 576 to 578 we are having the guard band, and suppose from 578 to 588 kilohertz I have allocated to another user. So if these two mobile units, those who are using the nearby frequency channels, it will result in the adjacent channel interference. That is why I said to you, whenever we are allocating the channels to the cluster, it is not like that the 10 consecutive channels are allocated to one cell. Rather, we will allocate it in the one to the one cell, second to the second cell, third to the third one, and in a suppose 3-cell cluster, there will be a difference of at least 3 channels between the two channels. Those are allocated to the same cell. In case of 4-cell cluster, there will be a difference of 4. In case of 7-cell, there will be a difference of 7 channels between the two channels. Those are allocated to the one cell. So by this way, we basically reduce this adjacent channel interference. But still, there is a possibility of adjacent channel interference if we are not using the good quality receiver circuitry. This adjacent channel interference is reduced by if we are using the good receivers. As discussed in first lecture also, the receivers plays a key role while discarding these interferences. Here in this figure it is shown that these are the two frequency those who are in nearby to each other. Due to the uh, due to the introduction of noise, these frequency bands go beyond their limits. As I said to you, actually the frequency band allocated to the user is suppose 576, 566 to 576, but due to the introduction of noise, it may go beyond that also. So you need a good filters. It is written here. It can be controlled by the transmitter as well as the receiver filters. So coping with the increasing capacity, as we all know, number of users are day by day increasing. In case of landline systems, we used to have only one landline phone in one family. Now in India, we have a population of around 125 crore or 130 crore. So landline number of landline phones are very less. But nowadays we have mobile phones. Each person is having more than one even SIM card. So channel we need the higher channel capacity. So that this can be possible with the help of if you increase the frequency spectrum, but frequency spectrum is limited to us for this radio communication. So the other option is you can do the, as I said earlier to you, you can reduce the cell size. That will result in more frequency use. In that case also you can increase the channel capacity. But suppose you have statically assigned the number of channels to a one particular cell. Suppose in a 7 cell cluster, there are 7 cells. You have allocated the channels. Suppose channel number 1 to 10 you have allocated to this cell. 10 channels are allocated to second cell, and next 10 channels are allocated to third cell, and so on. This is basically the static channel assignment. What happens? Suppose the number of users in some time, suppose there is one office in suppose cell number 1, and all other locations like suppose cell number 2, 3, 4 in a given cluster, these are basically the residential areas. So what happen in daytime, all the people will go to the office, and there will be the more channel demand in a particular cell. So that is why if you are allocating the channels statically, it will result in the congestion. So it was always better to allocate the channels dynamically depending upon the needs of the users. So what happens in this case? We allocate all the channels to the central allocating authority that will govern this. But this also has some problem. Whenever there is any call, it will be always through this central coordinating authority. So there will be a bottleneck problem in this case if your server is not of good capability. So to have a solution between these two, whether statically allocating or dynamically allocating, we allocate the channels statically to one cells, but we provide the facility of channel borrowing. We can borrow the channels, borrow the free channels. Those are available in the nearby cells if required. So this will not create a bottleneck problem, because if there is a central authority that will allocate the channel, every call, whenever there is a request for a new call, it will be diverted to that. So that may results in the bottleneck. So by this way, we handles the congested cells. As I have given the example of office, the requirement of channels at a particular instance of time in a day is varying. So, but still, if you do this like the dynamic channel allocation and channel borrowing, still there is a requirement of increasing the system capacity. The more number of users can be accommodated. This can be done with the help of cell splitting also. As I said to you, if you increase
एक्सक्यूज
the
मी
number
सर
of cells in a cluster,
सर
yes,
चंडीगढ़ यूनिवर्सिटी से बोल रहा हूँ सर सर इको आ रही है आवाज़ में बड़ी
there is a requirement of increasing
हेलो
just checking.
एक्सक्यूज मी सर
This can be done with the help of cell splitting also. Include university that we will be checking the connection. All the remote center coordinators are requested to please switch off their mic. All the remote centers coordinators are requested to please switch off, please mute their mic so that there will be no echo problem to the other centers. So moving back to the this how we can increase the system capacity. There are multiple options, like we have cell splitting, cell sectoring, and in micro cells. We can basically we want to decrease the cell size. That is possible with the help of cell splitting. Cells in areas of high usage can be split into the smaller cells. Like the cell sectoring, cells are divided into a number of wedge cells are divided into the number of wedge sectors, shaped sectors, each with their own set of channels. We can also have the micro cells. In each cells, antennas move to buildings, hills, and lamp posts. In this case, so all this will basically results in the increasing the system capacity by one or another way, by reducing the cell size and increasing the system capacity. By this way, we can split the large cell into the smaller cells so that more number of users can be accommodated, because there will be higher frequency reuse in this case. So we will do the cell splitting only that particular location where there is a traffic congestion, or where there is a requirement of more number of users. This is the cell sectorization, where we can sectorize the large cell into the smaller by placing the directional antennas. So each cell can be suppose divided into three subcells of 120° one sector. This is known as sectorized. Or we can have 180° sectors also. We can have 6 subsectors in a one large cell also of 60° each. So that depends upon the requirements of the system, how many users are basically there at a given time and how many users can be accommodated according to that. So if we divide basically the cells, more number of channels can be reused during the same day. That is why it results in the higher system capacity. Coming into the handoff, when we move from one cell to another cell, there is a change in frequency basically. To smoothly accommodate this change, basically we need this handoffs. Network protocol must refresh and renew paths as a mobile station host moves between the cells. Handoffs are the function of one cell handing over the communication link between itself and a mobile station as the mobile station moves out of the boundary of its region into the boundary of an adjacent cell. This happens because, as I said earlier to you, two nearby cells, because whenever a mobile unit will move from cell A to cell B, it will always be a neighboring cells. So no two neighboring cells are utilizing the same, or you can say nearby frequency. They are utilizing the different frequency channels to reduce the adjacent cell interference. There should be a accommodation facility so that whenever a user moves from one cell to another cell, it can be accommodated without call drop. So there is a problem from Chandigarh University by Viceroy to RM. So in this handoffs, we have two types of handoffs: soft handoff and hard handoff. In case of hard handoff, the frequency channel changes whenever a user move from cell A to cell B. This type of handoff, basically hard handoff, occurred in case of GSM. GSM utilizes the hard handoff. Whenever a user moves from cell A to cell B, frequency will definitely be changed. But in case of CDMA technology, whenever a user moves from one cell to another cell, it is possible that the same frequency is being used in two cells, because CDMA works on the principle of code division. They use orthogonal codes, and those codes are pseudo random and are quite far away in a range from one another. So on the basis of that, they basically identify the users. So this practice must preserve the end-to-end connectivity in a dynamically reconfigured network topology. And this handoff may require the different type of capabilities, because there is a possibility, like we have one pedestrian user who is moving from cell A to cell B. His speed will be near about 2 to 3 km per hour pedestrian, And suppose there is a person who is sitting in a car and car is going at a speed of suppose 100 km per hour. So for that we need the quick handoff. So there is a quite speed variation between the two different kinds of users. One is moving at a speed of 2 to 3 km per hour, another one is 100 km per hour. In that case, in both cases, we need a proper handoff so that there should be no call drop. That is only possible if we make the effective handoff before the channel completely goes off. So we basically makes these handoff on the basis of a threshold value. As soon as the signal strength goes below the particular threshold value, we check and we measure the distance on the basis of that, and then accordingly we make the handoff. And handoff may be of different kind, like we can see here in this diagram. There is a intra BSC's handoff, inter BSC's handoff, and inter MSC's handover. Just click on this. So we can see here the first, the mobile unit, or you can say base, your handset is basically connected to the BTS, and BTS are basically connected to the BSCs, then BSCs are connected to the MSCs. So whenever there is a handoff between the two BTS, it will be governed by the BSCs only. There is no need to report it to the MSCs, because generally BSCs are in a same, you can say, same zone. So in that case, there is no requirement of intimating it to the higher authority. But whenever there is a handoff between the two BSCs, we should report it to the MSCs, because it is required, or it needs to be maintained in the bills also. Suppose there is a roaming charges or other kinds of charges, those needs to be reported to the MSCs. And whenever there is a call between two MSCs, then definitely it should be reported to the two intermediaries. After this, we have GMSC also, Gateway Mobile Switching Center. We will report it to the that particular. But if in each case we report the matter to the MSC, then as I said earlier to you, MSC will be bottleneck, and the dynamically configuration of handoff will not be possible. In earlier, generally we used to have this handoff from the BTS or BSCs, but nowadays this handoff is governed by our handset only. Our handset basically analyzes the signal strength received from a particular BTS, whether the signal received from BTS A is higher or signal received from BTS B is higher. And as the mobile unit is mobile, it is also analyzing the signal strength, which signal strength is continuously decreasing and which signal strength is continuously increasing. On the basis of that, our mobile unit, basically mobile, say you have a handset, basically takes the decision. And this has been done to reduce this bottleneck problem, because if all the decisions or all the management principles are done with the help of BSCs or MSC, the effective speed up will be very low. This is another way out to accommodate the fast moving users and slow moving users. We can have a large cell on over the smaller cells, like shown in this diagram. We have one large cell colored with green, that is known as the umbrella cell, and we have smaller cells in between this also. So we are using here two different kinds of BTS. One small height BTS are placed in each cell, and one larger BTS, or you can say BSCs, placed all over this. This is to accommodate the fast and slow moving users. Okay, this umbrella cell, or you can say small micro cell, purpose of this is to accommodate the variation in the speed of these two, slow and fast moving.
Question, sir.
Yes,
TTC Jodhpur question.
yes, you can ask, sir. TTC Jodhpur, you can
सर्विस
ask.
प्रोवाइडर को कैसे पता चलेगा कि वो फास्ट मूविंग व्हीकल में फोन है?
Please repeat, sir, question.
How will the service provider know that the user is fast moving and the umbrella cell should be given to that particular user?
I have already said, sir, regarding this. this decision is to be taken by our handset, not by your cells or you can BTS. So basically, our handset is analyzing the signal strength as well as the rate at which the signal strength is increasing or decreasing. If there is a quick increase or decrease in this change in this signal strength, then our handset will not connect to these small micro cells. It will be connecting to the upper that I have shown in this diagram with the help of. So the decision is to be taken by our handset only. If the quick decay in signal, then it will be connected to the umbrella cell, and umbrella BTS will be
Thank you, sir.
utilized.
Thank you.
So we have already covered these modulations in the first lectures of this. We are utilizing ASK, FSKs, and PSK for digital modulation. Modulation is required for basically the long distance communication. Carrier is required. So all over these technologies are using this. And multiplexing is also uh, used by our cellular networks. In case of GSM, because this is the most popular type of cellular network in our country, it uses both FDM as well as TDD as well as time division multiplexing, or you can say time division duplexing basically. One thing we are having here is, suppose whenever we are making a call between the two person, basically not one channel, two channels are utilized. Ideally it is one, but two channels are required. One is the forward channel, another one is the backward channel. One channel is utilizing from sending the information from the BTS handset, another one is from handset to the BTS. If you are using a common channel, then there will be interference, like echo problem will be generated. That is why this forward and backward channels are separated. If you see the frequency spectrum, there is a quite big guard band between the forward and reverse channels. This is due to this. So frequency division multiplexing we are utilizing, time division multiplexing also GSM is utilizing. With a combination of these two, higher system capacity can be uh, accommodated. And I also said to you, because we have divided the frequency amongst the users, so more number of users can be accommodated. But how a particular channel can be time divided amongst the users? Suppose there is one frequency channel from 566 kilohertz to 576 kilohertz. How can we divide a channel amongst the users? Like persons are sitting in this room. How can we divide a particular channel amongst the users? Time bound and frequency division is possible. 566 to 576 I have given to one user, 576 to 586 to another one, 586 to 596 to third person. But how a channel can be allocated on a time division multiplexing basis? there is another there is another there is another possibility apart from this, is because in case of GSM the data rate generated by the user is quite low as compared to the data transmission rate provided by this GSM. So in other words, you can say the rate at which users are generating the data is very low as compared to the data transmitted by the GSM. We collect the data from multiple users, group it in a single GSM channel, and then forward it. One particular this GSM channel is not used for only carrying the data generated by the one user. We wait for a certain amount of time, collect the data from multiple users, and then transfer. Are using a one GSM channel on one particular call, then there will be a huge wastage of GSM channel. Already covered this TDM, CDM, FDM first session, so no need to cover it again. Just have a quick look at this slide. In case of FDM, everyone talks in a different room to prevent interference. Since the conversation can't be heard from another room and filtered from the other by going to the other room. This is the first example of FDA. Within each room, everyone takes turns talking to prevent interference. Within each room, one person is talking at once, so they must talk fast to say everything. So GSM uses a combination of these two, FDMA as well as TDMA. Because in CDMA, there are uh, infinite number of codes available with us. Combination of these two. Second picture shows the combination of these two, because in first you can see here only 4 calls can be accommodated. If you see the diagram, if you are using only the FDMA, only 4 can be accommodated. Likewise, if you are using the TDMA, you can accommodate only 4. Just taking an example. But if you are using a combination of these two, you can accommodate 16. That is why we go into this one. And moreover, you can see here this call 1, call 2, call 3, they are not using a continuous frequency band. This frequency band will be random, so that the further adjacent channel interference can be reduced. In case of CDMA, we don't have any scarcity of codes. That is why it does not require any combination of FDMA or TDMA. Only CDMA itself is sufficient, because we have infinite number of codes available with us, and these codes are orthogonal to each other. There is no possibility of repetition of codes. So CDMA itself is sufficient. This CDMA provides better protection against the interference, good security, and signal difficult to jam. So technically speaking, this CDMA is better, but I said earlier also, this CDMA requires the complex circuitry, which is costlier. That is why this CDMA technology is not popular in developing countries. This is popular in developed countries like United States. In European countries, most of the countries are using this GSM. CDMA that uses a pseudo random code sequence generated by the transmitter, and receivers are not always random. Fast power control system needed so that strong signals don't overpower the weaker signals. We've already covered this multiplexing. So the major problem with respect to the wireless, in wireless network with respect to the wired one, is a signal transmitted from a transmitter can be received by any any person can receive it. So we need a good, or you can say strong algorithms, so that user cannot decrypt the information. We need a strong algorithms so that our information can be encrypted in this, and a third person who is able to receive the signal but will not able to decrypt the information. But and this wireless networks are also having some advantages like flexible, cost is less, mobile users choice, which the networks they want to opt for accesses areas that wired networks can't reach. These are the advantages of. Disadvantage have all, the major disadvantage is the security aspect. Wireless network may include additional security elements which are not supported in the wired network, where we need the additional security arrangements. For that, we need to pay extra. That is why the cost of our handset that is used for cellular communication is quite higher as compared to the normal handset that is used for the wired communication. So the use of security algorithms like WOP, that uses an encryption algorithm with these will unauthorized access to the network eavesdropping can be used. These algorithms can be used in case of wireless network like data encryption standard, triple data encryption, advanced encryption standard, and there is a triple A algorithm is also there, which is currently used by the GSM. Moving on to a GSM network, that is the one of the popular kind of cellular network in our country. This is the general architecture of our GSM. You can see here we are having here the BSS and NSS. BSS is basically the base station subsystem. NSS is the network station subsystem. And the user is having the mobile station with the SIM. SIM is basically the subscriber identity module that is inserted into the handset, and after that only calls are possible. Then this mobile station is connected to the BTS, that is the base transceiver system, with the help of radio links. These BTS are connected to the BSCs, to the ABs interface. Those are generally the wired interface. These BSCs are connected to the MSCs, also with the help of fiber optics, and MSCs are maintaining the VLR, HLR, EIR. Basically, VLR is the visitor location register, HLR is the home location register, and EIR is the, it is with respect to the, so we will, when we will cover these more slides, you will come to know. And what is AUC? Authentication. So this MSC is maintaining all these information corresponding to each unit, and this MSCs, or you can say NSS, is then connected to the wired network, that may be your PSTN, ISDN, and other kinds of networks. We will move forward. Mobile equipment or terminal, it may be fixed, portable, or handheld. Generally, nowadays we are using the portable handsets. Base station, we are having the BTS, that is the base transceiver subsystem. Now, though we have already covered this mobile station, we have already discussed the BSCs. We will straightway moving to the MSCs basically, because MSCs are having the key components, certain key components like HLR, VLR, AUC, and EIR. And there is a GMSC, which I talked about earlier. Whenever there is a call between the landline to the mobile, there should be a gateway mobile switching center between these two. So MSCs, whenever are connected to the PSTN or any landline network, there is a gateway between these two. Now moving on to the home location register. Whenever a user is registered in a particular zone, there will be an entry in the home location register that is maintained by the MSC. It is basically a database. It stores the information about the subscriber belonging to the covering area of the MSC. It stores the current location of these subscribers and the services to which they have access. The location of subscriber correspond to the SS7 address of the visitor location register. This will come when we will discuss one of more sites. VLR, whenever a person moves from out of his or her home location, there will be an entry in the visitor's location register. The VLR contains information from a subscriber's HLR. It will copy the information that is available in the HLR of a particular user in another MSCs. वहाँ से copy करके it will be copied to the visitor location register. So it is necessary for the provision of subscribed services to the visiting users. Whenever a subscriber enters the covering area of a new MSC, the VLR associated to this MSC will request information about the new subscriber to its corresponding HLR. The VLR will then have enough information to assure the subscribed services without needing to confirm with the HLR each time a communication is established. AUC is the authentication center. It register provides the parameters needed for authentication and encryption of the function. Like suppose we have purchased a new SIM, we will register it. Then this authentication center will come into play. It will authenticate the new SIM with respect to the particular company. As well as whenever we make call, we check whether it belongs to a particular network. Suppose we are in a roaming, then it will check whether the particular user is having enough balance or not. Accordingly, these are required. And EIR is basically the equipment identity register. Whenever any mobile handset is stolen, or you can say its IMI number will be reported, and if it is suppose a stolen mobile or its IMEI number is reported, then EIR will not authenticate this mobile set, and you cannot utilize this mobile handset for making a call. That is why people says to always note your IMEI number of the handset, and if your mobile set is lost, report it to the police station. IM number is placed on your bill also. There are certain shortcuts also depending upon the which company of mobile phone you are using. It will be visible. In form of sticker also it is, yeah, certain codes are like star, but it depends upon manufacturer to manufacturer. It is not one standard code is there from which you can note this. So this EIR will maintain these kinds of information corresponding to IMEI number. So suppose whenever a mobile unit which is suppose located at this place, at suppose Chandigarh, a person wants to make a call to another person which belongs to Chandigarh, but now it is roaming around suppose Uttar Pradesh. So what happens? The call will first go to the from handset to the BTS using the radio link. Then BTS will connect the call to the BSC. Then from BSC it will go to the MSC. From MSC it will check if this number is registered with the Chandigarh, so it will check the HLR of particular this number. Then from there will be an entry. Whenever a user moves from his home location to any visitor location, then visitor location MSC will request the HLR that we need the information regarding to this, and it will maintain a pointer from this HLR to that particular VLR. So from where we come to know that this person is not in his home zone and it is presently at Uttar Pradesh. So from that, after that, the call will be connected to the different MSC, and from there it will go to the BSC in which zone it is currently roaming around, and from there to the BTS, and from BTS it will go to the particular hands. So this is the basically key role of HLR and VLR. This is corresponding to the incoming call. And likewise, outgoing call also, whenever we are in the moving to the other network, the link will be maintained, and according to the balance available in the mobile phone, it will check whether the enough balance is available for roaming or not. That is why these MSCs come into the picture. These are required. So I hope you understand the purpose of HLR, VLR, authentication center, authenticating the new SIM. Likewise, EIR, that is the equipment guarantee register, maintaining the information corresponding to the IMEI of number of the mobiles. Then comes is the operation, support and subsystems. Whether the complete network is working properly or not, they maintains this, and different components of the NSCs and BSCs in order to control and monitor the GSM system. It also takes care of controlling the traffic load on the BSCs. Load balancing is done at this place. Generally, few engineers are there, basically who performs this task on behalf of the whole network. This is not completely the automated work. So in GSM there are 5 main functions: transmission, radio resource management, mobility management, communication management, operation administration and maintenance. Basically these are the 5 functions performed by the complete GSM network. GSM network is already a packet network of sorts. Because of its frequency hopping, it requires no additional hardware to support data. We have already covered this frequency hopping and DSSS in the first lecture, where I thought to enhance the security, we hop to the different frequency even in a one call, so that even there is a third party person who is able to receive the information, he will hop to different networks. So GSM allows data rates in multiples of 300 bits per second up to 64 kilobits per second. These are certain advantages of cellular networks: less interference with other wireless communications, allows dynamic distribution of capacity, and so on. In the end, we can conclude that the mobile phone contracts provides a useful and relatively cheap service with respect to the landline. If you remember the earlier days when we were making any STD call with the help of the landline phone, initial bill was around 3 rupees 33 paisa around. But nowadays, even with the help of these cellular networks, the call rate is very low. Cellular, this is possible because more number of users can be accommodated with a single network. So cellular radio networks infrastructures are growing at a tremendous rate. So the rate at which the number of users are increasing, it is not possible to accommodate large number of users with the help of just the existing landline networks. But these cellular networks are able to accommodate the more number of users by changing the cell size with the help of cell sectoring, cell splitting, by using the umbrella cell, and so on. And the major drawback of earlier cellular networks, like the higher data rate, was not possible. But nowadays, with the enhancement in technology to 3G and 4G, we can achieve higher data rate also. Speeding up the development of mobile communication technology is the focus of the industry. The ideal communication system where both voice and data services can be delivered regardless of location, networks, or terminal. This is all for this session. Now it comes to the question and answer. If there is any query from the participant present at this center.
Yes, sir.
Yes.
The hexagonal cell diagram which you showed us is different for each service provider. Like each service provider has his own hexagonal cell network. Like Airtel has different, Vodafone has it on, or they share with each other.
So generally, these shapes may be different with respect to the different service provider. But nowadays, what happens? Suppose there is one BTS, or you can say in simple words, you can say there is one tower. So generally, that tower is shared by multiple service providers. There will be an antenna of three different service providers. Like suppose BSNL is also using the same tower, Airtel is also using the same tower, and suppose Vodafone is also using the same tower. They place their antenna onto the same tower to reduce the infrastructure cost. Otherwise, there is not enough space in our country due to the large population. We cannot place multiple towers in an already existing, or you can say already civilized society.
So on the same tower, they use different frequencies, of course.
Yeah. Yes, yeah. For that, they require the good circuitry that can filter out the unwanted frequencies. It is only then possible if you are using the good quality circuitry. Otherwise, it will not be feasible. And moreover, the frequency spectrum allocated to multiple service providers are also different. Same frequency spectrum which cannot be allocated to the different service providers. Any other question from the center, sir?
How satellite communication or satellite phones are different from the cell phones?
Because our satellite phones, they are communicating straight from our handset to the satellite. There is no BTS, there is no BSCs, there is no MSCs. So if you move from one suppose height to another height, your satellite phone will work. But the number of users that can be accommodated in case of satellite phones will be quite less, because there will be no frequency reuse. One frequency which is going from our handset to the satellite, the same frequency cannot be reused. So large number of users cannot be accommodated with the help of satellite phones. Any other questions, sir? Any other question from any participant present at various remote centers?
Sir, I'm from JIT Jodhpur, sir.
Yes, sir. Please ask
Can
your
you hear me?
question.
So sometimes in a cell, there is a mobile device with high battery life and better connectivity. So now when a user moves from one cell to another, it may create a situation of cell dragging. I mean, the cell with poor connectivity may contact with the cell with the higher connectivity, and it may work as an ad hoc for the cell which is moving outside. So how do the ISP deal with this situation when one cell move out from one cellular external to
Please not,
another
we are not able
maintaining
to
the same
understand
frequency?
voice is coming to us, but the quality is very poor. We are not able to.
So can you hear me?
We can hear you, but we are not able to understand what you are speaking.
So as I said, when one cellular phone moves from one cell to another,
Okay,
coming to the edges of the cell, it may lose connectivity.
please repeat.
Okay, from one BTS.
Whenever a cell moves from one cell to another cell, after that,
During this movement, it may lose the connectivity. I mean, the signal strength may go low.
yeah,
Yes, sir.
yes, yes,
And then, and then a strong cell which has got better battery life, better connectivity with the BTS station nearby, may act as the tower for the cell who is moving outside. It is called as cell dragging.
yes, 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 sir.
Therefore, how the ISP deals with the situation, ISPs, I'm sorry, how the ISPs deals with the situation when same frequency is moving into the another cell.
Yeah, sometimes it is possible. Sometimes it happens like this. The person or a user who is moving at the boundary of a particular cell. Because as I have already shown the diagrams, like the ideal cells are different from the it could be possible that the user is connected with a nearby cell or a frequency which is of similar, or you can say nearby frequency is used by any other existing mobile, then it will result in the interference. So we don't have any straightaway solution for this problem, sir, because as I said to you, this handoff is governed by our handset only. Service providers are not come into the picture for making the handoff. But generally, these types of problems happens very less. We all know there is the quality of cellular networks has been uh, tremendously increased. Now the problem of these call drops occurs very less. I do not even remember last time when there was a call drop in my mobile phone. So now there is such type of problems occurs very less. This is with the evolvement in the latest technologies and good quality of filters, sir. Any other question from any participant present at remote centers? I think there will be no question from participants from remote center. So thank you. We will be starting the next session soon. And as I said earlier, we will be having the validity session at 12:45. So thank you. So after 15 minutes, we will be having the next session. Thank you.
हेलो। ठीक है सर, ओके। ओके। हाँ, वो जल्दी आए, उस आईडी पे जल्दी आएगा ना, थोड़ा इसलिए होगा। और क्या, और कितनी चाहिए? चल तो रहा है, चार्ज तो है। क्या पता ये सारे काम है।
अब दो सेल तो दोनों डाउन करने लगा है, नया सेल लगा है।
नया नहीं है, वही चार्जिंग वाले चार्ज नहीं कर रहा है।
उससे में नहीं आता, सुबह जान तो क्या रहा।
कैमरा नहीं था तो हमारा और उल्लू करा दे।
पीटी 5 आके बंद हो जा रहा है, ये जल रहा है। अब इसको बंद रखो।
Chandigarh University, can you hear us?
हेलो, हाँ जी सर।
Can you hear us?
हाँ जी सर।
Can you see the screen?
हेलो।
Yes, sir. Kamlesh sir, can you see the screen?
हाँ जी हाँ जी
Yes, you
हाँ जी
know.
हाँ जी सर।
अच्छा, ये आपकी ही स्क्रीन है?
हाँ जी
सर ये देख लिए पार्टिसिपेंट कहाँ पर है?
सर, ये देखो पार्टिसिपेंट सर बैठे सारे।
जो व्यू है ना, कैमरा पार्टिसिपेंट की तरफ कर दीजिए प्लीज।
अच्छा सर एक्चुअली में पता क्या है, मैं अपनी तरफ इसलिए किया है क्योंकि स्क्रीन ना हमारी आगे है, तो सारे स्टाफ वाले आगे बैठे होते हैं।
तो सर
मैं इसलिए
कैमरा
मैं
फ्रंट ऑफ व्यू लगाइए प्लीज, फ्रंट में कैमरा लगाइए ना।
ठीक है सर। वो सर प्रोजेक्टर वाला सिस्टम हमारा दूर है, प्रोजेक्टर दूर है, तो इसलिए हमें वो थोड़ा करना पड़ता है, और कुछ नहीं है। ये देखो हमारी ये स्क्रीन है, इसके कारण ये सारे ये इधर बैठे होते हैं स्टाफ वाले।
इसे कैमरे का व्यू तो कीजिए ना, कैमरे का व्यू तो मुझे दिखाई नहीं देता ना, मुझे तो एक ही पार्टिसिपेंट वो लगता है, वो भी हनेरे में बैठा है जैसे।
नहीं
ऑन भी
नहीं
लाइट भी नहीं ऑन किया हुआ उसने।
सर, वो असली में सर
लग
खिड़की
रहा है
वाली।
वीडियो से आपका, आपके सामने है, आप देख लीजिए फोटो भी कैसे
नहीं,
है।
मैं समझ गया आपकी बात सर। आप पिक्चर जो क्लिक कर रहे हैं नॉर्मली सारे वो इस साइड बैठे होते हैं, प्रॉब्लम यही है और कुछ नहीं।
चलो सर, अभी कैमरे का व्यू पार्टिसिपेंट की तरफ कर दीजिए, फोटो 4 लेनी है मैंने अभी जस्ट।
ठीक है जी, हम लोग सारे इधर ही बैठ जाते हैं। आज इधर ही आ जाओ सारे।
JIT जोधपुर, हेलो। JIT जोधपुर,
हेलो, गुड मॉर्निंग सर।
मैम JIT जोधपुर से मैम।
सर रियायत जोधपुर। अभी ब्रेक हुआ है इसलिए फैकल्टी किसी कुछ बाहर गए हैं। विल बी कमिंग बैक इन 15 मिनट्स।
जस्ट मैम वेट, अभी। You can see the screen, ma'am. IIT Jodhpur. Professor Chetna Chaudhary, can you hear me? JIT Jodhpur. Hello.
Yes, sir. Sir, this side Chetna Chaudhary, JIT Jodhpur.
Yes.
कौन आ रहा है?
JIT Jodhpur.
Hello.
Yes, ma'am.
Sir, this side Chetna Chaudhary, JIT Jodhpur.
Ma'am, can you see the
Sir, am
screen?
I audible? Yes, sir.
Ma'am, your number of participants in your center?
Sir, they have just gone for a 15 minutes break. They'll be coming in 15 minutes.
18.
Sir, you said there's a the break for 10 minutes, so they'll be coming in 10-15 minutes back.
Ma'am, presently, ma'am, you see the screen of photo. You see the photo? Yes or
Sorry,
no?
sir.
Ma'am, you can see the
Sir, I
screen.
didn't hear you.
मैं आपको स्क्रीन दिख रही है जो आपकी डेस्कटॉप पे आ रही है ये नंबर ऑफ पार्टिसिपेंट 3368 is sleeping now
हाँ सर आ रही है.
morning session she is sleeping
Morning. And it was the university. Kamna ma'am received.
okay ma'am
Okay. I'm sorry sir for this.
पुनीत सर, MIT मुरादाबाद.
हाँ सर.
Number of participants.
सर 55.
This time to 55 and picture.
सर इस समय लगभग 30 अवेलेबल हैं, क्योंकि सेशन ओवर हो गया था तो कुछ लोग उठ के चले गए. फ्रेम में सारे आ नहीं रहे, मैं दिखा देता हूँ सर.
सर अभी ये फोटो सर सेशन के ड्यूरिंग सेशन की है, जो मॉर्निंग सेशन चल रहा था उस सेशन की फोटो है. टाइमिंग आप नोट कर लो, मैं आपको पिक्चर सेंड कर देता हूँ किस टाइम पिक्चर ली गई है. आपको टाइमिंग, ड्यूरेशन सब कुछ इसमें मेंशन होगा, किस टाइम पे कब पिक्चर ली गई थी, डेट भी आएगी.
सर इस समय मॉर्निंग शिफ्ट में हमारे यहाँ लगभग सभी की क्लासेस होती हैं, तो सर जिसकी क्लास होती है वो चला जाता है और जिसकी नहीं होती वो लौट आता है.
अभी मॉर्निंग सेशन की वीडियोस दिखा देता हूँ. मॉर्निंग सेशन अभी भी जो अभी आप आए बैठे हो इसकी वीडियो आप अभी देख लीजिए. ये वीडियो दिखा देता हूँ आपको, अभी की है, ये लेटेस्ट है, अभी जस्ट 5 मिनट्स पहले. ये स्ट्रेंथ आपकी लग रही है. ठीक है, चलो ठीक है सर, ओके.
ये उन्होंने स्नैप लिया है किसी टाइम का, अभी 10-15 मिनट पहले का. वो कह रहे हैं कि बस इतनी स्ट्रेंथ थी आपके यहाँ. सर आप करंट की स्ट्रेंथ देख लीजिए. अभी अभी सब लेक्चर से लौट आए हैं.
ठीक है सर, ये भी ले लिया मैंने वीडियो, ये भी फोटो ले
ओके
लिया.
सर. ओके सर.
ऐसे रखो, ये बिल्कुल ये स्ट्रेट पे रखो कैमरा, बिल्कुल स्ट्रेंथ होती है. ओके फाइन सर.
ओके, थैंक यू.
Urban Engineering College, can you hear us? Urban Engineering College. तो टूरबा करो सर, हटा ही दो इनका. 5 दिन का 5 दिन ही खराब कर दो, कैंसिल कर दो सेंटर. टूरबा करो सर, सर्टिफिकेट ही नहीं इशू करना अभी की बात. मैंने देखा नहीं सर, तो टूरबा कॉलेज को रिजेक्ट कर दिया मैंने. इनको सेशन लगाने दो, पर इसमें सर्टिफिकेट नहीं देना है. टूरबा इंजीनियरिंग कॉलेज. ठीक है, 4 पार्टिसिपेंट के भी 2 पार्टिसिपेंट.
रोज सर चंडीगढ़ यूनिवर्सिटी से बोल रहा हूँ सर. बंदे सारे एक आगे कर दिए मैंने कैमरे के.
ठीक है सर, फाइन फाइन.
ସେଇଟା ପଚାରିବେ କେତେ ଅଛି
Okay. Good morning, everyone, and good morning, ICT centers. Okay. चलिए सबसे पहले थोड़ा सा introduction, right? Something about me. Then we'll go to the technology, right? Okay. थोड़ा सा presentation form में है, so I hope you will like this. Okay. About me, my name Kapil Bhutani. My academic background, I've done MTech in telecommunication, MBA in telecom management. Prior to that, like all of you, I'm also an engineer. Then BTech in electronics and communication. My professional experience says I have been now currently I am serving as a technical director of a company named Telcocare Technologies Private Limited. It's based in Chandigarh, Mohali. So where we are looking for the telecom projects, trainings, and consultancy services for various operators and vendors. Before that, I worked as a trainer and consultant in a company named Techcom Consulting. It's based in Germany. This basically company also deals in the same way. It is in telecom trainings and consultancy. Trainings are basically corporate trainings for the telecom companies, for telecom professionals. And before that, I started my career from Ericsson India Private Limited, where I worked as RF planning and optimization engineer. अब यहाँ पे ये एक बड़ा एक सिंपल सा क्वेश्चन है कि RF प्लानिंग क्या है और ऑप्टिमाइजेशन क्या है, राइट? इसको सिंपल टर्म्स में हम लोग पूछे या समझे, एक बहुत लेमन टर्म में हम सब एक टावर देखते हैं, राइट? एक टावर है, एक सेल साइट जिसे हम कहते हैं। वो टावर जो हमारा लगा हुआ है, वो एक टावर लगाने की कॉस्टिंग 50, 60, 70, 80 लाख के अराउंड आती है, ठीक है? और ऐसी कोई भी अच्छी कंपनी होगी जिसका नेटवर्क अच्छा होगा, उसका कम से कम 5-6 हजार साइट्स एक सर्कल में हों। जैसे हम सिर्फ पंजाब की बात करते हैं, सिर्फ पंजाब में सिर्फ एयरटेल की मोर देन 5,000 साइटें। सो 5,000 साइटें को अगर मैं मिनिमम कॉस्ट 50 लाख भी लेके चलता हूँ, सो आई कैन जस्ट इमेजिन द कॉस्ट ऑफ इन्वेस्टमेंट ऑफ इंफ्रास्ट्रक्चर ओनली फॉर सेल साइट। ऐसे धीरे धीरे करते करते पहले हमने आर्किटेक्चर देखा बीटीएस है, फिर समथिंग कॉल्ड बीएससी, समथिंग कॉल्ड एमएससी। तो नेटवर्क आर्किटेक्चर बहुत बड़ा है, राइट? तो ये इंफ्रास्ट्रक्चर कॉस्ट भी बहुत ज्यादा बड़ी है। तो उस कॉस्ट को सही तरीके से यूज करने के लिए दे नीड टू डू प्लानिंग। सो आरएफ प्लानिंग द सेम थिंग, राइट? हम लोग आरएफ प्लानिंग के अंदर बेसिकली नेटवर्क की प्लानिंग करते हैं कि साइट के टावर को कहाँ लगाना चाहिए, कितनी हाइट पे लगाना चाहिए, कितना एरिया वो टावर कवर करेगा, कितना लोग उससे बात कर सकेंगे, कितना डेटा उससे निकल सकता है, कितना थ्रूपुट यूजर यूज कर पाएगा। इन चीजों को सब प्लान किया जाता है। सो आरएफ प्लानिंग एक ऐसा डोमेन है जो किसी भी टेक्नोलॉजी के लिए यूज किया जाता है, वेदर इट बी 2G, 3G, 4G, अपकमिंग 5G एज वेल, ठीक है? एंड सिमिलरली ऑप्टिमाइजेशन जो है ये टू मेंटेन द क्वालिटी ऑफ द नेटवर्क। जैसे हर नेटवर्क का एक डिफाइंड स्टैंडर्ड है जो ट्राई ने डिफाइन की है, टेलीकॉम रेगुलेटरी अथॉरिटी ऑफ इंडिया ने। इट सेज कॉल ड्रॉप शुड नॉट बी मोर देन 2%। जैसे एक नेटवर्क से एक दिन के अंदर 100 कॉल्स हुई तो 100 में से 2 कॉल से ज्यादा ड्रॉप नहीं होनी चाहिए। इट इज स्टैंडर्डाइज्ड केपीआई, की परफॉर्मेंस इंडिकेटर, जो ट्राई ने भी डिफाइन किया है और हर एक कंपनी अपना डिफाइन करके चलती है। एग्जाम्पल, हम लोग जैसे एक क्लास में 100 बच्चों को पढ़ा रहे हैं, सो वी हैव अ डिफाइंड केपीआई ऑफ आवर सेल्फ कि हमारा 100 में से 90% बच्चा तो पास होना ही चाहिए। इफ 90% या 90 स्टूडेंट्स हैव बीन पास्ड, सो हम लोगों की पढ़ाने का तरीका ठीक था। 10 हम लेके चलते हैं, किसने क्लासेस कम लगाई होंगी, कोई आया नहीं होगा, XYZ बिजनेस। बट अगर 10 से ज्यादा फेल होते हैं, देन वी नीड टू कंसिडर अवर मेथड ऑफ टीचिंग और हमारी गलती कहाँ रही, हमें वो कंसिडर करना पड़ेगा। सेम वे 2% कॉल ड्रॉप नेटवर्क अलाउस। 2% से ज्यादा अगर ड्रॉप हो रहा है, सो नेटवर्क नीड टू जंप इन एंड चेक की और इश्यूज क्या हो रहे हैं, ठीक है? यही चीज ऑप्टिमाइजेशन। अब ऑप्टिमाइजेशन के अंदर कॉल ड्रॉप तो एक एग्जांपल है। व्हेन यू इनिशिएट कॉल, कॉल कई बार लगती नहीं है, कॉल लग के कट जाती है, कॉल चलती हुई उसमें इंटरफेरेंसेस आ रहे हैं, उसमें से वॉइस ठीक नहीं आ रही, वॉइस ट्रैकिंग है, कॉल म्यूटिंग है। इस तरह की रूटीन की जो भी प्रॉब्लम्स है नेटवर्क की क्वालिटी को लेके, दैट इज स्टडीड अंडर ऑप्टिमाइजेशन। तो ऑप्टिमाइजेशन इंजीनियर जो है वो उस चीज को ठीक करते हैं। इन सिंपल टर्म हम कहते हैं टेलीकॉम में सब कुछ वायरलेस है, सब कुछ हवा में हो रहा है, बट हवा में कुछ भी नहीं हो रहा। जो भी चीजें हो रही हैं वो सब प्लान की जाती हैं, फिर होती हैं और उसको ठीक भी किया जा सकता है। चलिए, ओके, ये इंट्रोडक्शन से चलते चलते हम लोग किसी और पार्ट पे डाइवर्ट हो गए थे, ठीक है। सो बेसिकली ये दो तरह के जॉब रोल्स हैं जो टेलीकॉम इंडस्ट्री में एग्जिस्ट करते हैं। These are few part of the world where I have traveled to deliver training, consultancy and services. I've traveled to more than 20 countries and worked with more than 50 operators on the world. Operators, Airtel, Vodafone, Reliance, इस तरह के अलग अलग operators हैं, right? Okay. ये कुछ snapshots हैं, कुछ photographs हैं अलग अलग देशों में अलग अलग लोगों के साथ, और उसमें कुछ जगह मुझे कॉमन देख सकते हैं। ये तो सबसे पहले नीटर चंडीगढ़ की ही फोटोग्राफ है। I have been associated with NITTR from last 6 years, electronics and computers background में। ये साउथ अफ्रीका में थी। There are some people, there's a company named MTN। MTN जो है वो पूरे अफ्रीका की सबसे बड़ी कंपनी, जैसे एयरटेल सबसे इंडिया में सबसे ज्यादा चलता है, MTN सबसे ज्यादा चलता है। ये समय में पेन ड्राइव है, इस पे भी MTN का ही छोटा सा गिफ्ट है, येलो कलर का टैग जो उनका लगा हुआ है, ये उन्हीं के लोगों ने दिया था गिफ्ट। ओके, इस वन ऑफ माय कलीग सेटलिंग इन कोरिया। कोरिया में नोकिया सीमेंस को उन्होंने ट्रेनिंग दी थी। Similarly in Kenya, in Saudi, in Senegal, Senegal is again a Western Africa part, in Russia, and in Dubai। ये जो ट्रेनिंग है दुबई की, ये थोड़ी नहीं थोड़ा ज्यादा इंटरेस्टिंग थी, क्योंकि इसके अंदर जो भी लोग हैं आप देख पा रहे हैं, इसमें अलग अलग तरह के लोग, मल्टीनेशनल पीपल, few are black, few are white, few of them are Indian, one of my friend from Pakistan, और कुछ टर्की से हैं, कुछ टर्की से हैं, कुछ इस्तांबुल से हैं। सो वी हैव वैरायटी ऑफ पीपल इन दिस ट्रेनिंग, और ये ट्रेनिंग बहुत अच्छी थी। इट वाज फॉर 4G इटसेल्फ। तो वहाँ का एक नेटवर्क है इतिसलात नाम से, जो 4G लॉन्च करने वाला था, तो उसके लिए सारे ऑपरेटर ये लोग काम करते थे, एक्सपर्ट्स, और इन लोगों की ट्रेनिंग कि हाउ टू वर्क ऑन 4G एंड वो कैसे आएगा, क्या काम करना है। सो इट वाज वेरी गुड एक्सपीरियंस। दिस वाज इन नाइजीरिया। दिस इज वन ऑफ माय कलीग इन US। इस तरह से अकेडमिक ट्रेनिंग की फोटोग्राफ्स कुछ हैं। दिस इज वन ऑफ माय लेटेस्ट सर्टिफिकेशन ऑन LTE एडवांस। 4G है जो अपकमिंग इस टाइम मार्केट में है और आ रहा है, उसे हम LTE नाम से जानते हैं, और ये जो सर्टिफिकेशन है दैट इज ऑन LTE एडवांस, वन स्टेप बियॉन्ड LTE, जो अभी तक वर्ल्ड में कहीं लॉन्च नहीं हुआ है कमर्शियली, बट कमिंग टाइम में ये लॉन्च हो जाएगा। दिस इज अ सर्टिफिकेशन आई डन इन 2013। The company name Award Solution। Award Solution जो है वो वर्ल्ड वाइड टेलीकॉम प्रोफेशनल्स के सर्टिफिकेशन के लिए मानी जाती है। They are based in US। इनका एक ऑफिस इंडिया में बैंगलोर में भी है। So we done this training in Bangalore। और पैन इंडिया उसके बाद बहुत कम लोग हैं जिनके पास ये सर्टिफिकेशन है। I mean they can be counted on fingers। Okay, this was my general introduction। Now we will start with the technology। चलिए, तो मैं वेरी ब्रीफली मैं आपको एक 1980s से लेके 2020 तक इस 40 साल में क्या हुआ था, क्या हो रहा है और क्या होने वाला है, इसको बहुत क्विकली मैं इसको ब्रीफ कर देता हूँ, सो दैट वी कैन सिंक्रोनाइज विद ईच अदर। हमें पता लगे कि हम दोनों सब सेम प्लेटफॉर्म पे आ रहे हैं। जैसे हम लोग नॉर्मली मूवीज में देखते हैं, उसमें लिखा होता है 20 years बैक, तो एक लाइन लिखी होती है और सबके बाल काले कर दिए जाते हैं, सब बैकग्राउंड में चले जाते हैं, राइट। इमीडिएटली करंट में सब ठीक हो जाते हैं और फ्यूचर सबके बाल वाइट कर दिए जाते हैं।
हेलो सर।
हाँ जी प्लीज
सर, couldn't understand Hindi sir, can you go ahead and English?
I'm sorry, please come again।
Sir, couldn't understand Hindi sir, we are in Tamil Nadu।
Okay। I'm sorry, I'll keep it in mind।
Thank you sir।
Okay, right। So we were discussing, okay, like a Bollywood, I was saying like a Bollywood story, it starts from 20 years back and jumps to 20 years ahead immediately, The only difference is the color of the hairs has been changed in last 40 years. So the same way we'll discuss about the story about what has been done so far from 80s to 2016 and what is coming ahead. Okay, so starting from 2G, somewhere back in 1975 to 80s, in the era of 1975 to 80s, uh, the issue was 1G was already in the market. So the major issue was that we need to bring up a new system that can help the users to roam freely. I mean, they should have a roaming facility. Like if I'm sitting here, I'm moving from Punjab to say another state, Haryana, I should be having a roaming facility, right? Similarly, in Europe, different countries don't have the roaming facilities. Like if I want to move from Switzerland to say Paris to say um, Germany to Sweden, I cannot take up my phone. I have to leave my phone and I have to get a new system when I move to another part of the world. So in that case, there we the European people, specifically the European telecom body named as ETSI, it is European Telecommunication Standard Institution, they thought to make up a system that should work in the Europe standardized. So every part of the Europe should follow the same standards so that everyone can communicate. Right. So with this, like simple example, English. English is a global language. You go any part of the India or any part of the world, you can speak in English, and most of the world, part of the world, will understand your language, right? So as a global language, like it is something the global standardization that they have done, so that every part of the Europe should be connected from the mobile communication. So that's there they make a system named as GSM. The previous name was Group Special Mobile, specialized for the people, European people, so that they can move freely in the Europe, in their continent. Later on, many parts of the world joined the same system, and the name was renamed as GSM, Global System for Mobile Communication, something we know today. So this global system for mobile communication is a set of standards, set of specifications that is being followed globally so that everyone can communicate on mobile easily, or someone, if they want, can move from one part of the world to another part of the world using the same mobile system. Like for example, we can move from India to US to European countries because we have a mobile phone and everyone is following the same standard, same language, GSM. But those countries like Japan for 2G, they are not following GSM as the standards. So even if we take our phone to 2G there, it will not work. Because I'm talking about 2G specifically for now. With time, these things changes. So in 2G, this was not possible to move in every part of the world with the same phone. That was 2G, specifically GSM. But nowadays in India, we have come up with the smart SIM, or we'll say some specific companies, those who are offering you the SIM cards that have the facility of international roaming. That's to incoming call free of cost. Either ways, if we are using the SIM card of any private company, Airtel, Vodafone, Reliance, they're charging us heavily. Like there used to be charges like 280 rupees per minute as an outgoing call, 140 rupees per minute as an incoming call, which has now been reduced. But still, we have some company like Matrix Cellular, Unique Connect, Cape Telecom. They're offering us free incoming call. We can roam in any part of the world where they have their connections or the setups, and in an outgoing call will be varying 3, 5, 10 rupees, not more than that. These facilities or these SIM cards are mostly available on the international airports. Okay. Even nowadays, we are having the facility of calling even at the height of 40,000 feet. So that means even if you are on the flight, you can make a voice call. Last month I was in Dubai. So I just clicked some photographs so that I can share it with all. Something like this. Okay. So this is a remote of the TV that we have in the flight, and just on the back side of this we have something like this. This is just sort of a mobile phone which has the facility of dialing the numbers, and you have the button to dial and to disconnect the call, and for the volume as well. And the way the call has been made is from this. You must be having a swipe a credit card specifically, which you can swipe through here. Once you dial the number, swipe the credit card, and you can press the green button, the call will be through. But the call rate is a little bit high, but if you need, you have it. The call costs $5 per minute, which will cost you around 300, more than 300 in fact, a minute. But yes, you have a facility. So if someone wants to avail it, they can avail it. Even nowadays, few of the flights are offering you Wi-Fi facility as well. That means they have the Wi-Fi facility. You can use it on the plane for 1 hour or for full flight. I bought a plan. It was a 1 hour for $10. For full flight is for $20. So at the cost of that, if required, you can get the Wi-Fi facility for whole of your flight. And for business class, they are free of cost. They are offering free of cost. I mean, not free of cost. It's already included in the price. Right. It's wrong to say they're costing free of cost. Okay. Yeah. Okay. So okay, this is little bit new. What is new in the market with respect to 2G? Then long time back, after 2G was or after GSM was evolved, it came up with 2.5G. Right. Something called GPRS that we use nowadays specifically for data. So we have already observed a lot of time that there is something called something like G is written on our mobile screens, on the top of our mobile screens. Where we see our mobile signals, we see something like G. That G stands for GPRS. In simple term, General Packet Radio Service, that can offer you a maximum speed of 140 kilobits per second. So we will be talking about the speeds from here till 4G and so, but please, I'll like you to draw your kind attention on the same, that all these speeds are hypothetical. That means theoretically maximum possible in the lab conditions and in a very idle conditions, which in real network is not possible at all. But when we need to sell it, we have to tell about this. When we need to sell a car, we'll talk about the top speed. We'll not talk about the road conditions. Right? Okay. So, example, what actually in idle condition meant for? Idle conditions say that the site should be, you should be very near to the site, very near to the antenna in fact. So as we know, most of the antennas are been mounted above the tower. So they say if you are probably above the tower in front of antenna, then you can expect to get this speed. First, second condition says that above the tower in front of the antenna, you should be the only user. So you're not allowed to climb with anyone, or you should hold everyone downstairs, and you should be the only user above the tower. In that condition, you are able to get this speed. Not yet. Because the first condition can be fulfilled, you can climb the tower above, but you cannot stop others to do those. So with this, because when it is tested in the labs, in the lab condition you have an antenna just in front of you, and in front of you you have the dongle that you have been using. Of course, but it is in the testing phase, so no one else is using that, because no one else is having that dongle or that device to use. So that is the only condition where it is being checked. And mathematically this is true. But practically, of course, we have lots of constraints. Okay. So that is 2.5G GPRS. Then moving ahead, we came up with Edge, enhanced data rate for GSM evolution. This is something what we call it as 2.75G, right? 2.75G is Edge will offer you a maximum speed of 473 kilobits per second, right? So this speed could have been achieved in 2.5G as well, but few of the features has been enhanced in 2.75G. Like we have come up with the higher modulation. It was not in 2.5G. We came up with something called linked adaptation, or we call it as adaptive modulation and coding scheme, right? The faster, the nearer we to the site, we'll get more modulation. We'll go far away from the site, we'll get the downgrade of the modulation. Coding scheme also keeps on changing. So with different features that has been enhanced in Edge, it's named as enhanced data rate for GSM evolution. Right? Okay. Any doubts still here, please? Remote centers, please. Okay, please. Hmm. Actually, there is no as in the hidden charges. The thing is that there are two different perspectives. One is technical and one is commercial, right? One was talking about this research, right? But nowadays, it's not just the voice call that users are doing. Most of the users or most of the revenue which any telecom company is getting from is data. Voice call is not the source of revenue these days. I mean, not a good source of revenue these days. The data, and without data, no one is surviving. So we have data charges, data packs. So initially, which was been offered in 90 rupees, 4 GB data pack, and for full month, now it has been 198, 190, 200 rupees, the same data pack, and user has been increased. So as a burden, if I'm talking about a specific user, he's not spending much on the call, he's spending more on the data, right? Because from data he can do multiple things. So as a user, if we say also another perspective, like initially we used to have 50 paisa per minute, right? So we were bound to talk for a minute or for 2 minutes. Right? I still remember when I joined Ericsson, so we were being given some free minutes, and then after 3 minutes we used to talk like this. I guess, I mean, I'm on the phone. Most of my concentration was on a timer at times. It should not increase, it should be always in the even, like yeah, it should not go above 1. If it goes above 1, it should not go above 2. So I have to cut the call before 2, so I compress my words this way. So that was 50 rupees per minute, 50 paisa per minute, right? Now we have 1 or 1.2 paisa per second. So if we calculate it for a minute, it costs 72 paisa, right? So it has been increased now.
Excuse me, sir. So this is Chandigarh University, Kamal Singh Saini. So I have a query, like why do we go for the roaming charges as for if we move from one state to another state? As if we talk about within state, if we are moving within state, that then also we are in the roaming only. But when we move from one state to other state, why there are roaming charges? Why it is not free? Or what are the main problems that can due to which these are not being done?
Okay. Well, your question is almost same. It both falls under the commercial category, I'll say. Uh, about roaming, I'll say that I believe, as far as where I've traveled, India is the only country where we have the roaming facility and roaming charges where we are paying. No other part of the world has something like state to state roaming. Right? Uh, the major reason is the commercial, I mean the revenue part, and the policies that we have in India, regulatory bodies. For example, a simple example, if I say, India has 22 telecom circles. Like if I say about Delhi, our state, capital state, so we have Delhi, Noida, Gurgaon, Faridabad, Ghaziabad. They all fall under same circle, right? So we don't have a roaming facility there. Though Noida and Ghaziabad is in UP and Faridabad and Gurgaon is in Haryana, right? They all are commercialized in same circle. Similarly, we have 22 telecom circles in pan India. So the pressure on the telecom operators is that they need to buy the spectrum in every circle individually, which in any part of the world is not been compared. Like if you're talking about the MTN is bought, MTN say in South Africa or in Ghana or in Nigeria, they have bought a spectrum say for 10 megahertz and they are using that 10 megahertz in complete country. And now in here, if you're buying 10 megahertz, Airtel 10 megahertz, Punjab, Airtel 10 megahertz, Haryana, Airtel 10 megahertz, Rajasthan, Airtel 10 megahertz, say Madhya Pradesh. So they have to bought every time every spectrum individually. UP is and UP West, exactly right. So that they have an overburden on that because of this spectrum cost, and the cost is very high, some hundreds or some thousand crores, not less than that. So in that case, now they have to put up their revenue, they have to get the revenue, and of course, we are the source of revenue. We have to bear, right? At the end, right? Like for example, continuing your question answer, Airtel is a company that have the network in pan 22 circles of their own, but in few other companies like say we have Idea or we have say Reliance also have it. So Aircel, right? Docomo, they still don't have their network in all the circles, but they are offering us the services. So for offering us the services, they need to have some roaming agreement with the company that have their network in that state. That is known as inter-circle roaming agreement, ICRA, inter-circle roaming agreement they have. So that also cost very high. That they are also in some crores per month. They definitely have to charge, right? But as India is one of the most populated countries of the world, so every telecom company is blessed with this as well. And every telecom company wants to jump into India because China doesn't allow anyone, and India is khule dil ka hai, so everyone can enter. So everyone want to enter because for mobile communication we need population, either it for data or it for voice. We need more population, more users, and we have that. We are blessed with that. So in this case, like I was in Africa, South Africa itself. So one of the gentlemen asked me, even I was surprised to see the stats. I was not aware of this, that the population of whole African continent is less than the Indian population. I was not even known that. So they asked me, I mean, just they was trying to, they asked me that why are you and how you are so much in number. So I say I didn't find so much population in India. Maybe statistically it's true, but I didn't find so much people around India. But since then when I'm traveling in India specifically, I see a lot of people, and I actually realized the question asked was true, and we really don't have the answer. So, but the fact is that's true. Okay. Anyways, so sir, did I answer your question, please?
Yeah, actually, sir. Actually, it is TTC Jodhpur, and actually, many telecom companies are using fraud management system.
Sorry,
my first question is, what is the working of the fraud management system? And second, what are the different types of frauds taken place in the telecom network? And third one, what is the intensity of fraud in India? And last one, how it helps increasing the revenue of the telecom organization?
I'm sorry, sir. The first two questions was not clear. Please, can you repeat the question?
What is the working? Just I want to know the working of the fraud management system. Those actually that software, softwares, telecom service providers are using basically.
Software, like okay. Let me repeat the question. What I understand, you want to know about the software the telecom companies are using.
No, sir. Fraud management system. For fraud management, what type of softwares are being used? How many types of frauds are there? And
what is the intensity of the frauds?
Statistics and intensity of fraud.
Okay, in the fraud management right now I get actually the word fraud was not clear. So understanding something called management. Okay. Specifically, if we talk about the fraud management, it is not very high nowadays. In fact, earlier it used to be, because earlier the system was very new, specifically with prepaids. Postpaid was not an issue because postpaid systems were already built for a month, were being checked for a month, so it was not an issue. Major issues was with the prepaid connections, which earlier was very high. So to overcome that, they come up with some new devices or some new uh, infrastructure. They call it as IN, Intelligent Network. Maybe we are aware of the word MSC, right? Mobile Switching Center. So for postpaid subscribers, users, billing, subscribers profile, everything has been done in MSC for postpaid users, right? And for prepaid users, we have a different system, entirely different system, that is known as IN. We call it as intelligent network. Intelligent network basically is entirely different system that actually handles prepaid users for billing, for authentication, for subscribers services allowed, for balance checking, and for credit users and limits. So this is I'll say it's not a specific software. It itself is a complete department and a different machine or different equipment that is being used. IN is the name for that. Right. So as in, if I say about the fraud, like there is no. It used to be long time back that people used to get the negative balance of 1,000, 2,000, and so. It used to be long time back, but nowadays this is not possible. Since IN is so intelligent, for example, now we from ourselves we call it as prepaid, right? Because we pay it and then we get the services. Similarly, during the call, like for a simple example, these days, if we are on a call and our balance is about to finish, it will give you a beep during the call. It will give you a beep to define or to warn you that the balance is about to exhaust, right? So how it is able to do that? Because every 2 seconds he is checking you, he's checking upon you that the credit is not finished, or are you the right users, are you the user who should given this service or not. So every 2 seconds he's been checking, right? It can be come down to every second, it can go up to every 5 seconds. Depending upon the company, they fit their own parameters for the same. So with these parameters and these companies have the IN system, which actually works so fast and so intelligently. Simple example, we are sitting here, we make a call. The moment we finish the call, we get the balance on our phone, right? So they are every time have a look on you. So these frauds in these cases are probably very minimum these days. And for SIM cloning, if I talk about, this is a type of fraud can be possible. SIM cloning used to be there, but nowadays the authentication process is so tight that without knowing a secret key, which is only known by the network and the mobile user and the mobile SIM, you cannot authenticate yourself. Right? There's something like a pin code is given to two users, and only two users knows that. Right? No third user knows that. So without knowing that, no one can clone the SIM. They can clone the SIM, but it will not work. Okay, did I answer, sir?
Thank you, sir.
Okay. You were asking some questions, sir. I guess we left it. Right, 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 right. Yes, true. You can say reducing. Right, 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 right. True. Hmm. Right, right, right. Hmm. True. Right, right. True. Okay. For example, now the same thing that we discussed now. So much is investment has been done by Indian operators that they need to get the revenue. Specifically, when something is new in the market, it is always costly. Like for 4G, 4G will not be so much costly as compared to 3G. But 3G, when it entered the market, it was complete change in the architecture, and also the the spectrum cost of 3G overall was 65,000 crores, which is very very high, unexceptionally very very high. So now operators need to fulfill that requirements. It was just no no at every step. Of course, those who intend. Very true, very true. So mm, right, technical process. Right. No, research in till if I, okay, if there is some controversy here from 2G to 3G, research and technology says it will not be cost effective. It will be expensive only because equipment of 3G that work on WCDMA transmitter and receivers are costly. So every company who has to have to install something called Node B that work on WCDMA will not be cost effective for companies as well, and not for the users as well. But moving towards 4G, which now working on OFDMA, is quite cheap, quite easily available, and quite cheap transmitters and receivers, like we're already using in Wi-Fi. These devices like this. So for companies as well, these devices are quite cheap. Spectrum cost is very less, right? Because spectrum range is very high, spectrum cost is very less. So spectrum cost is increased for operators, their equipment cost has been decreased for operators, and so they're not going to charge high from the users as well. So the plans for the 4G which will come in the market is compared to 3G. I mean, similar to 3G. Even they can offer it on the lesser price as well, but they don't want to disrespect 3G as well. So they are offering it on the same price of 3G. The difference between the services of 3G and 4G is far better. 4G is far better than 3G. Right? So as what they are bearing, they have to get from us also. And since we are the source of revenue for them. So OFDMA is cheap, so 4G will not be expensive. Lower, exactly right. And because uh, that is possible, but let me tell you the latest news. True, 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 right, 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 true, true. No, here also your words is right. The perspective of the company is different this time. Actually, what they want to do is they want to first make the market at a lower cost. Market strategy, right? So the perspective is same, but the model is different this time. Like for example, it was in news that Reliance Jio is coming with the biggest network of the world for 4G, will offer us there's 75 GB of data plus 4,500 minutes of calling just at 200 rupees per month. Reliance will offer. I mean, they have not commercially launched yet, but they will offer it soon. So once they can offer this, they are going to make a big market, of course. So as you say, quality cost is also a quality parameter. This will fall in because not only the cost, Reliance Jio is also going to give us the quality as well because they have invested more than 1 lakh crores. So they actually are going to give the quality as well. Yes, exactly right. It seems a new brand now. Right. And they are coming with the well, that will be off track. Off track. Exactly. We'll discuss after the session. Okay, right. Okay, moving ahead. Quickly to 3G. Now, with 3G, in 1996 it was started. The story came up with 2 Mbps of requirement from the ITU. ITU says we could require 2 Mbps of speed. How to get it? They outsource the work. So in 1998, they everyone come up with that WCDMA should be the technology on which 3D should work. 3D can, I mean, 2 Mbps can be achieved by using WCDMA as in the multiple accessing scheme. So in 1999, first 3G network entered the market. NTT Docomo was the company who commercially launched it first time in 1999. It in itself was a complete change in architecture. Then in 2001, there was a little change in architecture, like we say something called MSC, right? In 1999, our mobile station of 2G became UE of 3G. Architecture was changed. Let me just write it here. So the architecture of 2G was like this. So 3G was like this, where MS of 2G became UE, user equipment of 3G. Our BTS became Node B. Our BSC becomes RNC, Radio Network Controller. Our MSC remains the same. This was in 1999, but in 2001, the changes came with the MSC. MSC was split into two parts: MSC server and media gateway. For example, we know in 2G we cannot support multiple services simultaneously, right? We cannot do data with voice. Either of them can be done, but both of them cannot be done. But in 3G, it is possible to have both simultaneously. Right? Till since 1999, it was not possible because MSC was the same. So signaling and traffic both were handled by the same entity itself. But in 2001, it was split into two parts. One was handling the traffic, another was handling the signaling part. So media gateway was responsible to handling traffic, and server was handling the signaling part. So with this change in architecture, we were able to support multiple services simultaneously. Then in 2003, we come up with HSDPA, high-speed downlink packet access. Dongles came into the market. 3G was most respected, and it offered us 14.4 Mbps of speed. In 2005, we came up with HSUPA, high-speed uplink packet access, that can offer us 5.76 Mbps in uploading. So this normally we see on our phone by the name H written on our phone. Then came up with HSPA plus some enhanced feature 3.75G that can offer us a maximum throughput of 28 in downlink and 11 Mbps in uplink. So again, feature was enhanced, MIMO was introduced, modulation scheme was enhanced, and so the speed goes to 28 Mbps. Then moving ahead to then 4G, then the requirement came up with a different. Till 3.75G, the network was too complex. I mean, increase every 2-3 years we see we have some new architecture, some new feature. It's like, because it's just a step enhancement. It's right, right. Well, I'm sorry. Maybe I also don't know the answer for this. They can be. It can be 3.1, 3.2. Right, right, right. So really, I'm sorry. I didn't know the answer for this. I'm also trying to find it out. If I get something, I'll get back to you. Okay. So now this is something out of the rule 3.9G. So something what we claimed as 4G is a pre-4G network, initial 4G or demo 4G network, which nowadays is well known as LTE, long-term evolution. Right now, the reason why we came up with the different architecture this time was first the complexity of the architecture. Till 3.75G, the network was too complex. So many interfaces, new protocols have been changed that now the technology makers says we'll make something good and something for long term. We'll not make a change for every 2 years. 3, 5, 7. In 7 we get HSPA. So actually plus one. You say we'll not make changes after every 2 years. Rather than this, wait for 2 years, make something good for long term. So inspired from that, they make LTE. The name resembles the technology long-term evolution, something that will last for long term. So in this, architecture was very specific. Of course, more than that. Right. So they say the technology will be simplified, not very expensive. Architecture will be simplified. Speed will be much higher. Even we can say more than 10 times of 3.75G. So that every 2 years we need not to experiment something new. So the architecture was changed this way. Okay. Now, as we say, we have UE in 3G. Okay, I've lighted there. It is 3G. And for LTE, the architecture was changed this way. Our UE became EUE, evolved user equipment. User equipment of 3G became evolved user equipment of LTE. Our node B became E node B. And luckily now RNC and node B was compiled together to become E node B. So that means this E node B a very small equipment which can be mounted just behind the antenna above the tower, can handle the functionality of node B and RNC itself. And RNC in size was quite big, and node B itself was. So this E node B is given so much responsibility and is been made so smart that it can handle node B and RNC combined together. MSC was a core network, so we introduced some new elements here. We have MME, we have HSS. We have SGW, and then we have PGW. So these four was been connected with E node B. Yes. Right. So E node B to MME and E node B to SGW, we have the connection. MME is simply mobility management entity, something handling the mobility of the packets. Like if I'm moving from one site to another site using some data, my mobility need to be maintained so that there is no packet drops, there is no reduced in speed, and my connection should not be break. So we have MME looking for that part. Similarly, we have HSS, home subscriber server, for the database of the user. All the users database like my subscriber profile, my subscriptions, my plan, my home address, everything is been stored in HSS. SGW is serving gateway, one which will give me the packets, and PGW is packet gateway, which will get the packets from the external internet network. So in simple term, MME is signaling, SGW is packet, the same way we have MSC server and media gateway. Here MME is looking for and SGW is looking for packet for data. This is a brief and simplified architecture for LTE. And the good thing here is that E node B is very small in size, so this can handle most of the responsibilities, and at times he may need not to ask for MME or SGW for anything. He can take his own decision and give it to the user. He can have his own buffer and give it to the user. And since we say E node B is a site, a tower near to us, so it can serve us every time very fast. So the round trip time will be less. For example, if as a student we want to get some permission, so first we will write a letter and we'll get it signed from lecturer, then maybe from HOD, then maybe from the principal as well. So if the lecturer itself has the facility, it has a right of power to sign the authority that you can proceed, then round trip time will be less, and so the work will be faster. The same way, E node B has been given those rights that you can proceed immediately. Okay. Any doubts, please still here, please. With respect to this or without this as well. Any questions, please? Remote centers. Okay. Any question, please? No, they are completely new, so they are definitely replacing the previous one. Right, right. So if you want to use this, it's not right to say replace. It is just adding on. Right, 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 right. Then it will be only LTE. Right, or not. Then it will be only LTE. But if it, nowadays we are coming up with the equipments, single equipment who can handle 2G, 3G, and LTE all together. Like a single equipment who has BTS, Node B, and E Node B embedded in the same. to simplify that. If if you talk about the coverage for LTE, it now depends upon the radio spectrum that we are using here. Like LTE offers, like in 2G, we were having the limit that we can use 900 megahertz band or 1800 megahertz band. In 3G, we came up with 2100 megahertz band. In LTE, it offers a range of starts from 700 megahertz band. We can use till 2600 megahertz band. Very huge range. So there are 43 frequency bands that can be used in this, right? So those bands which are available, try can sell it to the operators and they can bought it and get their work done on this. Example, we have been using 2600 megahertz band. Airtel is using 2300 megahertz band is being used. Now Reliance have come up with 850 megahertz band, and now 700 megahertz band is already in the market that can be utilized. But the cost of spectrum is very high. For I guess each single megahertz of band is more than 11,000 crores. So if any company wants to buy a minimum of 5 megahertz of band, that will cost them around 55 to 7,000 crores, which is very costly. But that will be very effective because it is small in frequency, so it will cover a large area in coverage. In that case, they will be able to save the cost of infrastructure. They will not require to have multiple sites. Sites can be put in the far distance, but the cost of spectrum is very high in that case. So now they have to choose. They want to chase. They want to pay to try, or they want to pay to the vendors. Ultimately, they have to pay. So 700 megahertz, right? Exactly right. So the range now depend. For if you example, if they are using 2600 megahertz band, so the range will be very less. It's very high frequency, range will be very less. But that can offer us a deep penetration, like in the underground areas, uh, multiple stories area, right? We can have a good coverage in central malls. We can have a good coverage. Okay. So we were discussing in this LTE. We started about LTE and its architecture a little bit. Then, if this is LTE, LTE advanced is this, which we said the certification I show you initially. That is the real 4G network. This real 4G network says LTE or 4G will be something that offers you a speed of 1 gigabits per second. Some technology that can offer you 1 gigabits per second will be known as 4G. Something that at the speed of or at the high mobility of 500 kilometers per hour. That means sitting in a bullet train, you will be able to receive 200 to 300 megabits per second of speed. That will be real 4G. The delay should be less than 10 milliseconds or even 5 milliseconds else. The latency should be less than equal to 5 milliseconds. Something with these features will be a real 4G network, and that real 4G is LTE Advanced. That is in terms of GSM, 2G, 3G and 3GPP. Another way, we have Wi-Fi, WiMAX and so WiMAX Advanced as well. It is IEEE standards. Ma'am, I mean, seriously, again, it is true. Below extent, true, very true. Even sometimes I am also surprised to see what I am reading is actually working or not. I mean, it is actually. Well, it has been tested till now. We have able to achieve 700, 800 megabits per second speed. I mean, in US, AT&T, T-Mobile, they have been testing it. They've not commercially launched it yet, but they have been testing it and they are able to achieve these speeds with a latency of 10, 12 milliseconds. they have been majorly using it because the major market in the US is the youngsters is with the online gaming. So online gaming is one of the major markets they can get the revenue from. So for the online gaming, they need the minimum latency. So they have been testing on it and they are able to achieve it. Maybe again on the lab conditions, but they are able to achieve it.
So currently it is 3.9G or 4G?
Currently, what we have been using in India, or that is coming up in India, is LTE is 3.9G. But of course, we in the market will not say it's 3.9 or 4 or something. We kill it at 4G. You might have seen the advertisement 4G slash LTE. In most of the advertisement, we see 4G slash LTE. LTE is mentioned with the 4G as well. For example, we get a 3D SIM where we get H and H plus as well. If you go to buy a dongle, they say it has 3G dongle, right? But we didn't get only 3G on it. We get 3.5, 3.75G as well. So from the marketing point of view, it is kept as a layman 2G or 3G or 4G, but the real sense what is being used is 3.9G as per the specifications. LTE advanced.
Do you have one more slide for 5G or advanced technologies?
I can make it here.
Yes, please, sir.
I just added on to LTE advanced. Sure. Ma'am, you are asking something. Sorry. Sorry. Right. Exactly. Right. 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 Very near future. Like proposed 2020 or 2022, we can get something like this. It has been proposed. Rest, how much time it will take, we will not say, but this is achievable at times. But it depends again on, again, this is till now it is on lab conditions only. Once they enter the real scenario, right, then things will be different, right. Then only we can say, yes, this is the drawbacks which we was not seen in the lab conditions. Now we are getting in the real lab.
Sir, one more question.
Yeah, please.
Like there was 2G, then there was 3G, then 4G. So every time the hardware at the base station changes on the towers and everything.
Major changes came up with these equipments. Like in 3G, we came up with Node B on a tower. Rest of the equipment is same. Like if you are aware of the rest of the equipments, would you want me to add on those equipments as well?
No, sir. Got the point.
These will be changed. Node B and eNode B, these will be changed. Okay, let me like for example.
Okay, so it is a layered structure, so some particular layers would be changed.
Like okay, for example, let me just show you this in the real picture. Like it is a cell structure with antenna and microwave antenna, everything. The shelter room, right? Just near the tower, you have a shelter room where you have all the equipments, right? We have microwave rack, we have battery banks, we have DDFs, we have SMPS, we have rectifiers inside the SMPS, we have PAU, we have BTS. This is equipment named as BTS. This BTS is from Nokia Siemens network, NSN. Similarly, we have BTS of Ericsson, right? This is specific to 2G. Similar structure like this will be for 3G, known as Node B. Something really small, just 1/4 of this size, will be known as eNode B. So this is the major equipment needs to be changed on the site. Or if it is not, like we discussed, it may not be, it's strong to say it has been changed. It needs to be added on the site if you want to have that site running 2G, 3G and 4G altogether. So we need to add these three different equipments and their respective antennas on the tower. these antennas need to be added with different node Bs or different technologies. Or nowadays, we are coming up with an equipment that have 2G, 3G and 4G all together in the same cabinet. And we are coming up with the antennas also who can transmit on 2G, 3G and 4G all three technologies. Only challenge is they're highly they're expensive for now, and those companies who are not in a big plan, they'll just not move on to that. So they are having 2G, they're having 3G. You just need to add on a 4G equipment rather than replacing all and getting a new equipment. That will be not cost effective initially, but for long term it will be. That depends upon the company policy what actually they are looking for.
One more question, sir.
Is
Telcocrats provides training for engineering students also?
yes, sir, we provide training to engineering candidates, to corporate professionals, to faculties as well. So three different levels of training we have.
So we can see on your website.
Yes, let me just write down the website here. Yeah, maybe I having all.
In all the slides it is mentioned.
Okay, if you further want, you can have this contact details of mine. You can log on to the website and you can see the like in the training curriculum, we have designed 20 different modules, and all those modules are relevant to a specific job role in a company. For example, in my introduction initially, I say I worked as an RF planning and optimization engineer. So RF planning is one of the module, and optimization is one of the module that we trained upon. For corporate professionals, they want training on a specific module. For engineering or diploma candidates, they want training on all the modules.
Thank you, sir. This was useful information.
Thank you so much. Mhm. Mhm. Okay. Like a tool you said, let me see if I can have something. Yeah. Um, Let me see. At all, like the tool you asked about, I don't know, maybe it will work here or not because I know the don't know system configuration. At all is one of tool that we actually use these days for planning of the network, as we say. Like this is one of the area. Like for if we say coverage, coverage is something that we cannot see. I don't think it will gonna work here. Coverage is something that we cannot see, but coverage is something that we can predict, right? So prediction of the coverage is being done on the atoll. So for different technologies like Wi-Fi, WiMAX, CDMA, 2G, 3G, HSP, all technologies that we discussed for now, any of the technology can be planned here. We can put up a real scenario, buildings, clutter, type of people, profile of the users, all together can be put as an input in the tool. On that basis, we can plot a site. We can plot the parameters of the specific technology we are planning for, and based on these inputs, he will give us the coverage prediction. How that coverage will be, will look alike. Of course, it will be different from what will be in the real ground, but it can help you to get the real idea of how it will be, so that we can plan the base station locations and the number of base station we actually are looking for. Right? And then moving ahead, once they have been planned, they have been installed on the real grounds, and after that, this can be changed. So we have a complete lab setup for atoll. We have like licensed tools for atolls and For testing of the wireless network, we have a complete lab setup where we do the real network testing and real network planning as well, as in the projects for the companies, the consultancy for the companies actually. So we also get our students trained on this. For example, at all is not working, but I have a screenshot of the same. Also one video. So this is about LTE channel, call flow neighbors. The planning steps, how actually we plan the network on this specific atoll tool. Let me show you some screenshots. So as this is the frequency bands available, they are frequency band as we say 43. Choose one of those upon whom you want to work. Then these are the parameters now. Like we say, we know we have the control channels in 2G, in 3G, and in LT. So all that is planned, like it is PD, CCH, physical downlink control channel, physical uplink control channel. These are the parameters. RB, the source block, symbol duration. So everything is been planned. So what we do is first, like for the corporate, what actually they required is we want to do planning for LTE. That's the course. So first we teach them about LTE, and then we teach them on this tool how to plan the network. So these are all the parameters of a cell site. What are these parameters? You put in the parameters, it will give you an output. As I say, starting May, everything is in air, but nothing is in the air. Right? Everything is in air because everything is invisible, but everything is planned at the back end, and that is what has been transmitted. Then for the coverage prediction, this is a prediction. It will show like that the coverage. This is a site with 1, 2, and 3 sectors. It is giving us a coverage in this area. These different colors shows different signal strengths. Like an example, I have a real.
So this is simulation which you showed just now.
It is a sort of simulation, right?
And is there any way to get a picture of the actual scenario?
For the cell, for the coverage?
Yes, sir. Like I am not asking about taking a car and moving with a mobile with the equipment to see the signal strength on all the roads, but is there a direct way to get a view of the whole thing?
No, sir, I'm sorry. This is not possible. We can see something like this, or what can be done is what actually, if I talked about what actually in real sense we get is, like you said about drive test for now, getting the equipments and phone in the real field, we do some testing, and on that testing we collect the data and record it, and recorded data is being converted in another form to show it in a presentation form. So we actually cannot see a real photo, real picture of how the coverage will look alike, but we can actually get from that testing what are the signal strengths, or what is the range of signal strengths we are getting in that specific area.
Sir, I have a suggestion, or you can say idea.
Please.
आजकल आपने शादियों में भी देखा होगा कि फोटोग्राफी ड्रोन्स वगैरह से होती है, तो देयर कैन बी अ ड्रोन, a small quadcopter type of aircraft which can hover all over the city and get the parameters about the signal strength and plot a graph on the computer. So this type of product would be useful to the telecom industry.
This is a very great idea, in fact, I'll say, but the only thing that actually has been different from the real scenario is, okay, we have the engineers working upon, and the drone is carrying the camera. So the equipment which is used for testing is
No,
little
no,
bit.
sir, I'm not talking about the camera. Camera was just an example. It would be having the sensors to get the signal strength.
Okay, okay,
Various type of sensors.
okay, okay, right, right. And the only difference is that
It will log the signal strength with the latitude and longitude data after every 5 meters of distance. It will there would be a SD card on that device, and it will log the current latitude, longitude, and the signal strength.
in fact it's a nice
And
idea.
then give a geographical map like you are showing this map to us right now on the screen.
Right.
So it would be linked to Google Maps, and using the KML language of the maps, it can plot this type of data.
It sounds good. In fact, sounds very good. In fact, the only thing is, instead of sensor, if we can put something like mobile phone to get the real picture, because sensors may be different from the mobile equipments to get the right the accurate reading. So if this could be added, it will really save a lot of resources. In fact, I'll say. Nice idea. In fact, appreciate it. What's your good name, sir, please?
My name is Dr. Alok Singh Gehlot from MBM Engineering College, Jodhpur.
Great. Thank you, Malok sir. I'll really like to get in touch with you further on this.
Sure, sir. I'll drop you an email.
Sure, right. Thank you so much. Okay. This is like a plot. Right? It's not a coverage plot. This is RSCP coverage plot. This is PG. Showing us a site and the coverage that has been, which we get after planning of the network. Real network of a real testing, of course, will be better. And something like this, if I say, we have lots of things like this. I would also like to draw your attention here as well. Sort of a tool that is used for defining the parameters. One all we use was for planning the parameters, and this is for defining in the real network and changing in the real network. This is for different companies. ZT, ZXG10, ICM. For different companies, we have different tools. All look alike. Huawei have its own, Ericsson has its own, Nokia has its own. They all look alike. This is much simpler because this is GUI, graphical user interface, so you to understand. Like as we say, we have 8 time slots. Most of us knows we have 8 time slots being used, right? In TDMA, GSM. All these 8 time slots are being planned. In 0 to 7, 8 slots. We have some control channel in first 2 time slots, and then after we have further 6 time slots for traffic channel, full rate. So these are all also be planned. For example, if we say looking at a site, maybe say we have 6 cards. 1, 2, 3, 4, 5, 6. These are known as DTRU, Dual Trans Receiver Unit. Specific to 2G I am talking about here is Dual Trans Receiver Unit. Each DTRU card is able to handle 2 frequencies, that is 16 time slots or 16 calls. Each DTRU is able to handle 16 calls, but here we have seen that time slots is been reserved for the control channel. This 6 or out of 16, 2 will be reserved, and rest 14 can be used for calling. This we need to do for different sectors. Like for example, like we divide a site, a cell site in three sectors. Like in all the sites here, all the presentations here, you see we have a site, three again. First one, second, and third. Every site has three, three basically three sectors, three antennas. So how actually we do it is to divide each site on in three sectors. It is something like predefined. On the basis of filter actually the nearby area that actually we need to serve. For example, if you see here, tree is different from this tree. Third one is here. This here. 1, 2, 3. 1, 2. So this might possible. This area has a lot of people rather than this area. So we make this possible because we make this use possible because this helps us for easy planning. And if I can draw it here, it will be easy for me. This- Okay, this is for example a cell, and we divide it into three parts. Like this cell that is giving a coverage. Say it this way, right? You sector first, second, and third. So a site has been divided into three parts like this, and each part is being served by a single antenna. Now, let me again show you this picture. This picture has here antenna on first site, first sector, second sector, and if you can see here, third sector. On three sides. Here also you have first, second, third. Have antenna in three different sectors, three different angles. Now it depends upon the sector what actually they need to serve. Maybe in this sector first, this is second, this is third. Sector has a building of 30 meters, so we have to put our antenna above 30 meters. Sector may have a building of just 10 meters, so we will put a sector on above 10 meters, antenna on above 10 meters. Or may have 20, so we'll put antenna above 20. You see difference in the height here as well. And individually each sector, and we need to put the antenna individually for each sector. And each antenna is being served by two cards here. So two DTRU will serve a single antenna and a single sector. Right? We have 6 DTRU, 3 antennas, 3 sectors. So now statistically, if we come back to the call once again, we said we have 16 calls in each sector, in each card, so in each DTRU. But we also added we have control channels as well. We have the control channels too, right? So out of those 16, or I'll say out of 2 cards, I need to have at least 2 time slots for control channels. So in these two cards, where we were supposed to have 32 calls, 2 will be reserved for control channels, rest 30 will be used for the calling. So in each sector, I'm concluding it, each sector there are 2 cards, there are single antenna, in 2 cards we have 32 time slots, 32 users, at least 2 will be given for the control signals, so 30 will be left for the voice calls. So 30 in sector first, 30 in sector second, 30 in sector third. This is in 2G. In 3G, we don't have time slots, we don't have TDMA, we only have WCDMA. So we have codes. Wideband code is in multiple access, so we have codes. Now, theoretically, it says one 3G site can have 127 voice call users. As per the number of codes, we can have 127 voice call user in a single 3G site. But as per the limitations of the regulatory and power, we can, and interference as well, we cannot go more than 60 calls, 65 calls, keeping in mind that we are also allowed to use data as well, along with the voice call in 3G. So we could have 60 calls along with the data users. In 4G LTE, once again, it is not TDMA, not WCDMA, it is OFDMA. So we can have multiple users. Now that will depend upon the frequency we are using. On 4G, there is a limitation. As we say, we can use the frequency start from 700 megahertz to 2600 megahertz band. So the frequency that is being used will define the number of users that can have that site can have. So we cannot fix it. But if we talk about the maximum, we can have 20 megahertz of band. 20 megahertz given to a single site that can serve around 100 users. Maximum interest. But minimum and lots of things will be varying depending upon the configuration. Okay. The question was asked about the 5G. In 5G, frankly, nothing has been standardized yet as per my knowledge. I've been looking for it last long. Meetings have been done, proposals have been made, researches have been going on, but nothing has been standardized. Because with every technology, there's some standardized specifications. Like for 2G, ETSI has done it. For 3G and 4G, 3GPP has done it. For 5G, nothing has been standardized yet. How it will work, what will be the architecture, what will be the protocol, what will be the channel, what will be the interface, nothing has been standardized yet. But it is, again, researches and papers have been developed, which has been giving us the technology named Li-Fi. Right? That could be one of the technology coming up with the 5G. Looking at the limitation from the spectrum point of view, like with every technology, we are limited with the spectrum. There is no frequency, no spectrum, so no speed. So they are now trying to use light as a source of transmitting of data. So Li-Fi is something related to that, that can give us a speed more than 1 terabytes per second. Like University of Surrey in England has tested something like this. Lots of universities, lots of research has been going on this, but specification has not been done yet. This IoT, Internet of Things, that also falls something under 5G category. So different publishing, different papers have been given. So I'm not specifically saying anything right or wrong, because I'm not sure about everything what has been right or what has been wrong in this case, since we don't have a specifications on this. Yes, but this is something sure. This is going to, because every new technology has come up some previous drawbacks. So drawbacks were the reason why it come up with the new technology. Here is the spectrum. Speed is already very much high. So here is the spectrum that actually we have the issue with. Okay. Any more questions or query, please? More centers and everyone. A white space is it? Okay. 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 I'm sorry, I don't have an idea about it. But thank you again. You have given me a new homework now. I will start working on it. It's a white space, right? I'll, right. Hmm. Right, right, right. Okay, right. Okay, okay, right, right, right. Okay, right, right. Yeah. As far as I think about it, is if we have a licensed spectrum and still it has been not used, there should be some good reason for this. Like for example, we have some frequency ranging from 1920, I mean for 1900 megahertz band, 18 for some from size 1920 to 1980, and that cannot be used because some some common frequency of that is already been occupied in 1800 frequency band. So that is not in use in India. That can be used in any other part of the world. That has been used in fact in any other part of the world where they don't have 1800 megahertz band, but where they have 1800 megahertz band, they cannot use 900 because the frequency overlaps. And if they use, it will cause huge interference to the network. So even if we have, we cannot use it. It is licensed, it can be bought, but cannot be used. So with this white space, if I'm getting it right, if this is the issue, there is some reason why it is not being used. So this is the reason. If this is the reason we're not using it, so we are bounded not to use it. Hmm. Okay. Hmm. Right. 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 Hmm. 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 Right. Right. Hmm. And that will be used only for data transmission itself, or for any purpose. Any purpose. I don't think we have something like this because it will be a security threat then. Security issue will be highly there. Of course, it is true. Right, right. True. 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 Right. Right. True. Right. 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 Right.
हो गया
Uh, well, for unlicensed, I'm not sure of now. As of now, we don't have any feature or facility with this. We have something relevant or something like this, that there's something called frequency reframing. I mean, if 2G is using some frequency, but later on Airtel wants we don't want to continue with 2G on the same frequency, we can use same frequency, same spectrum to utilize 4G network. And 4G can be rebuilt on the same frequency without much tension. Because the rainfall is the same, right? Right. Even this is possible that frequency can be used. Few of the spectrum can be used for 2G, few can be used for 4G. Out of 900, few can be for 2G, few can be for 4G as well. This is also possible for protocol or different applications. Something like this that you propose for now, I haven't heard of it till now. Maybe in the coming future, this will be in the market. Yeah, because since we are all having this the deficiency or excess of spectrum, right, right, and that is not been utilized. So this may be in, it's not been utilized yet. Right, right, true. That is what where optimization comes in. They have the full space and they are utilizing the small space. Okay, in remote senses centers, do we have any question, please? I guess then we should wind up for the day. You have my email ID, contact number. In case you have any query, any doubts, anything, any new notes, any specific topic you want, you can write me or anything regarding training. You can always ask. Thank you so much. Thank you so much.
Hello. I request all the remote center coordinators to be prepared for valediction. We will start it within 5 minutes. So if you have your chief guest with you, you can call them within the next 5 minutes so that we can join you for the valediction. एक आप ही के कॉलेज में कोई प्रतिभा है, वो मुझे कॉल आया था, आप लोगों लगा शायद आप ही के कॉलेज से सेक्टर 11 की बात कर रहे थे। गवर्नमेंट का ही था, विमेन का था शायद, कौन कौन सा 11 में ही। तो आई वाज एक्चुअली कंफ्यूज, मैं कौन से में का सैम है। आपका कौन सा है? कोड वन। मुझे सो मच सेक्टर 11 में गवर्नमेंट में कॉलेज जो भी है सेक्टर 11 में है, देख लो कौन सा है। बट वो टेक्निकल कॉलेजेस नहीं है ना हमारे, तो हमने तो टेक्निकल का ज्यादा पता है हमारा, जितने कॉलेज हैं यहाँ पे नॉन टेक्निकल। थैंक यू सर। So, welcome back participants present at NIIT Chandigarh and various remote centers. So, this is the last session of this 5 days AICTE recognized short-term course on wireless network. In this STC, we have started from the first session that was on wireless communication basic, in which we covered the fundamentals of wireless communication, modulation techniques, and multiplexing techniques also. Then, according to timetable, we had the session on IP addressing, but unfortunately, due to some emergency, we have to swap some of the sessions. And on that day, we had a session on firewall configuration and access list. Although that was slightly difficult for the participants, because before the IP addressing, it was slightly difficult to understand it. But in future, we will take more care regarding this. After that, we covered the WSN, that was covered by our expert from industry. He has shown us too much about the hardware kit that can be utilized. And after that, we had a session from expert from CSIU Chandigarh, who had given you the theoretical and research aspects on wireless sensor network. Then we covered the Bachelorette of Network by Mrs. Meenu Kurana, who has given a wonderful experience about the VANET, how they can, the future prospects of intelligent transportation system that can be utilized for intelligent transportation for vehicle monitoring, as well as multimedia applications, how there is supposed traffic jam ahead, how the other vehicles, those who are coming behind, they can take the alternative route depending upon the prior information. These are the benefits of intelligent transportation system. Those are yet to come in our country, but few of the applications of VANETs are still also existing. After that, we had a session on wireless body area network. That is one of the key aspects of wireless sensor network, and a lot of research is going on this area. That was covered by Mr. Bali on this. So after that, Mr. Saurabh Kaushal and Mr. Amit Dogar, they have covered the concepts of IP addressing and Wi-Fi issues, how what are the various security issues in case of handling the Wi-Fi, and how Wi-Fi network can be made more secure. Then mobile ad hoc networks was covered by Dr. C. Ramakrishna. He has also covered the various applications as well as issues and challenges in case of mobile ad hoc networks. He has also given a brief overview about the security aspects in case of managed. And today we had a session on cellular technology, starting from the 1G to the 4G. So I hope the participants have gained something from this course and understand the various aspects of wireless network. So I would like to take feedback from the participant present at NIIT Chandigarh and at various report centers. So starting from the participant at NIIT Chandigarh, we will start from the remote centers. Okay. Let's start from remote centers. So this is SCS VMV University, Tamil Nadu, Kanchipuram. Coordinator is Mr. K. Shivkumar. SCS BMB University, Tamil Nadu.
Yes, sir. This is Shiv Kumar.
Please introduce your chief guest, if any, and please give feedback from the participants those present there.
No, sir. Actually, as of now, no chief guest is present here, sir.
No problem, sir. No participant.
Any feedback, positive or negative, is more than welcome.
27, sir.
I would like to take the feedback from the one or two participants, those who attended this course. Any suggestion, any feedback from the participants?
Sir,
Like to.
Yeah, good afternoon, sir.
Very good afternoon.
Good afternoon, sir. This is Prasad from SHPM University. Sir, the sessions were good, and only one request from our side.
Yes,
hello.
sir.
So what are the thing is, it is for 5 days it is not possible to attend as a whole. So that's our request. So can you reduce the sessions, not the sessions, session duration?
Okay, sir, actually we are conducting the different types of short-term courses. That is a 4-day short-term courses. We also conduct 2-week short-term courses. We conduct 3 days short-term. If you want to.
No, what the issue was, actually we have a faculty shortage, so in a rotation we are handling this issue.
So that's meant for only 2 days.
Okay. Okay. Thank you.
Regarding the about the scope.
Sir, not clear your voice. Not clear your voice.
Okay. Now moving on to the C.V. Raman Engineering College, Bhubaneswar. C.V. Raman Engineering College, Bhubaneswar. Dr. Patti is there. C.V. Raman Engineering College, Bhubaneswar. Is my voice going to C.V. Raman Engineering College, Bhubaneswar? Dr. Patti? I think we are not able to make the connection to C.V. Raman Engineering College. Now moving onward to the MMEC Mulana, Dr. Kuldeep Pava will be there. MMEC Mulana. MMEC Mulana, Dr. Kuldeep Pava. Okay, I think due to some technical issues, we are not able to make the connection MMEC. Moving onward to JSS Academy of Technical Education, Noida, Dr. Seema Shukla.
This is Dr. Seema Shukla. Good afternoon, Dr. Rakesh. Today we have with here our chief guest, who is Professor S.N. Srivastav. He has an illustrious career in teaching as well as in BHEL, and currently he is the director of 2 IT companies, and I'm going to hand over the mic to him now. Thank you.
Welcome you, sir.
Hello, my best wishes for your this workshop, for all the effort that you have made. I wish you all the success in your efforts. Thank you very much.
Thank you, sir. Thank you for your wishes. Now we would like to have feedback from few of the participants, those who have attended this course.
Okay, can I just say something first?
Yeah, ma'am, definitely, please.
This was quite an interesting session, and plus there were some topics which were new and nice, like Zigbee and VANET and all. But there's one observation, although, that there's some technical problem, particularly when somebody asks a question from some other center. We are not able to understand the question clearly. Perhaps there's some audio problem. So that is one aspect of this whole system that you need to look into. Uh, Apart from that, things were good. And just one request from all our participants here, that kindly share all the slides. You shared slides for one day. Kindly share all the slides, particularly the VANET slides are much in demand here. Now, I want to invite two of my participants here. One is Mr. Arun from KEC.
One thing here, all these sessions are available on YouTube, madam. You can go to the
Okay, thank you. Yeah.
and all the complete video recording of all the sessions are available.
Okay. Okay. We'll refer to that then. I will share this information with the participants.
Any other participant from your center want to give the feedback?
Yes, yes. He is Mr. Arun from KC Ghaziabad.
Good afternoon, sir.
Very good afternoon.
So I'm Arun Agarwal from KC Ghaziabad. So all the sessions were really highly informative, and apart from that, all the
Loudly.
sir.
Please speak loudly.
Okay. All the sessions were really informative, and apart from that, it is the advancement of technology that we and Ghaziabad itself are able to convey all the information that are delivered by the experts right there in Chandigarh. So it's a good step in remote education and all. Thank you, sir.
Thank you, sir. Thank you for a valuable feedback.
Hello, sir. I'm working as an assistant professor in IT department. The workshop was very informative, but from my opinion, that there should be some practical session. And you told us about the latest technology like Zigbee and WWAN, but there should be more slides, or you can say there should be more presentation on the latest research going on in this area.
Thank you, madam. Thank you for the suggestion. Actually, madam, when we are conducting these types of courses on ICT mode, it is very difficult for us to make practical session in this, because the expert will not be able to demonstrate all the things simultaneously using the video conferencing to this. So I suggest, if you want to attend a course in which more practical session will be there, better to come at NITTTR Chandigarh. Here we conduct the courses in which we have 4 sessions, so that the participants can get enough time for the hands-on experience. Although here we have some of the facilities that cannot be shown with the help of video conferencing. But your suggestion is noted down. We will definitely take into consideration next time when we are planning the timetable for the course, to introduce most of the session in a practical manner that can be possible with the help of, simultaneously with the help of video conference. Thank you, madam.
Okay, we have with us our principal, Dr. Kamal. He also wants to say something.
Yes.
Good afternoon. I am Dr. Kamal. I think I came in the inaugural function here, and I found that all the delegates have attended this course. They are happy with the course overall. Only what I also observed here is that in general there is a problem of audio. This was not so in other courses which I also seen that they were going very smoothly. I think some of the participants have already raised this for this time, that audio difficulty is there. Secondly, in earlier sessions also I mentioned that you can request the director, your director, saying that this kind of course can be in a mixed mode. That will be ideal, especially seeing the subject as one of the participants raised this, that in Wi-Fi system, and you also agreed that there is a need of having face-to-face as well as ICT mode kind of this presentation. So you can just give this feedback to your director, and my earlier request, if he considers, maybe next courses will have some this kind of mixed code. Okay, thank you very much.
We'll pass on your message.
Thank you. Thank you.
Thank you, ma'am. Thank you. Thank you. Now we're moving onward to the MIT Muradabad. MIT Muradabad. Mr. Puneet Rai is there. Muradabad, I think connection.
अपने टीचर बुला लीजिए
Engineering Indore.
Hello. Yeah, sir. This is Narendra from PCVT Indore, and our chief guest, Dr. Ji Joshi Madam, is here with us.
Yeah, sir. Please continue.
Good afternoon, everyone. This event was a very, very successful workshop. I think the technical knowledge.
लेवल सब ब्लॉक है पीछे
एक आध बार मैं फोन कर दूं। जिसका नंबर है एक आदमी फोन कर दो ना।
Please continue.
मैडम में तो मैं कर रहा हूँ, एक को कर देता हूँ, सारी आ जाओ। टीचर्स में एक आदमी को फोन कर दो। हेलो जी, कर देना, एक दूसरे को फोन कर दो, मैसेज। हेलो गीता मैडम, वैलिडिटी हो रहा है, जरा आ जाओ इधर प्लीज।
Ma'am, please continue.
मैडम थोड़ा जल्दी आ जाओ।
सर एमएमयू का माइक म्यूट कर दीजिए प्लीज। एमएमयू का माइक म्यूट करवा दीजिए प्लीज सर।
Truba College को दो, मैम बोल। Truba College of Engineering, मैम please continue. उनका माइक ऑन। संतोष, नरेंद्र पाल सिंह।
Yes, ma'am. Please continue now.
Truba College of Engineering, ma'am please continue. Okay, we will move to the next session and come back to this Truba College later. Moving on to Chandigarh University, Kadhua.
Yeah, good afternoon, sir. This is Kamalji Singh Saini, so coordinator from Chandigarh University. So it was a nice session, especially for the if we talk about the VANnet and yesterday's Saurav Kaushal sir's that was related to hacking, Wi-Fi hacking. So it was a nice session. So we will require that there should be more session on these on Wi-Fi, as we were requesting to Saurav sir yesterday also. So if a special session can be there on that. So on our behalf from Chandigarh University, our head of department, Mr. Dr. Neeraj Sharma, he is our chief guest. So he will be responding.
We welcome you, sir.
Thank you, sir. Good afternoon, sir.
Very good afternoon, sir.
I interacted you during our inaugural session as well, and my faculty has reported that this session was quite informative, and certain suggestions are also coming from faculty side that cyber security and cyber forensics should also be included in the course curriculum, if you can do that.
Definitely, sir. Introduce.
Yeah, these are required to be in detail. So if it is possible, it should be included. Second point is that if it can be a regular practice that you can continue with 2 hours in the evening or some particular time for particular subjects. So that can be very much helpful, and it should be in journal.
Okay, sir.
So with this, thanks a lot, sir. Thank you.
Incorporate this. Okay. Moving on to the next. Moving on to the next center, that is JIT Jodhpur. JIT Jodhpur.
Hello. Good afternoon, sir. This is from JIT Jodhpur. Hello.
Continue.
Am I audible, sir? Hello. Am I audible, sir?
Continue, ma'am. Continue.
Okay. So sessions were really interesting, and almost you covered all the curriculums also. Most interesting ones were like Vantage and WN, and simulation also was very good. We came to learn how to simulate Vantage on LS3, and IPSC session was quite missing one actually, and we were interested, but it was very good. All over it was completely, and especially like when we covered at WN, so we came to know the new research areas into wireless network and Vantage also, and all over it was good. And some technical problems were there, like especially day before yesterday, some technical problem came with for 45 minutes we were not able to listen to the audio, and other technical problems are like anyone who was asking for the questions, the questions were not clearly audible to us. So we were not able to understand those questions that was asked from other remote systems also. And all of it, and we are looking for, in future we are looking for, like if you can conduct ICT workshops on W-band or mobile computing. So it will be more beneficial for the people because we are having those papers into our current semester rules. Thank you very much, sir.
Ma'am, just ask whether you got my points or not.
Hello. Hello. Hello.
Ma'am. Sir, listen.
Hello.
Hello, sir. This is
Yes,
JIT Jodhpur.
मैम बताइए प्लीज.
Sir, am I audible?
Yes, ma'am, you are audible.
They are audible. Yeah. No.
Hello.
Yes, ma'am, we can hear you. Please continue.
Yes, sir. Have you received the feedback? Hello.
Yes, ma'am, please continue.
Okay. Thank you, sir.
Okay, moving on to Jodhpur, Mr. Narendra Kumar. Jodhpur. Jodhpur. Please switch off the mic of JIT Jodhpur.
TTC Jodhpur.
Yes sir, from TTC Jodhpur.
Yes, sir.
सर बहुत अच्छा सेशन था एंड हमें बहुत कुछ सीखने को मिला. स्पेशली राकेश सर आपने जो सेल्यूलर टेक्नोलॉजीज वगैरह बताई और अमित सर से मैं आईपी एड्रेसिंग सीखने को मिला. सौरभ सर ने हमें प्रैक्टिकल वायरलेस नेटवर्क्स कैसे लिनक्स सिस्टम पे यूज कर सकते हैं और उसके हैकिंग के बारे में बताया. यूजर को सिक्योरिटी के लिए अवेयर रहना चाहिए. तो दैट वाज द ओनली प्रैक्टिकल सेशन व्हिच वाज हेल्ड एक्चुअली. एंड मिस्टर कपिल बुटानी ने एक्चुअली मार्केट में क्या हो रहा है उसके बारे में बताया. सो दिस वाज अ वेरी यूजफुल short term course for all of us, for the teachers. Though I have a few suggestions. सर जो डेमोन्स्ट्रेटर्स आते हैं, जो एक्सपर्ट्स आते हैं, उनको एक्चुअली कुछ पॉइंट्स अगर पता हो, लाइक मुझे ऐसा नहीं कहना चाहिए, लेकिन ये जो ऑडियो की प्रॉब्लम हो रही है ये इसलिए है क्योंकि मास्टर कंट्रोल चंडीगढ़ में है. Like if another participant is asking a question from, let us say, Bhubaneswar or from Tamil Nadu, we can't listen the question of that particular participant because that center is muted in our center. तो अगर ये मास्टर कंट्रोल वहां पे ढंग से हो पाता है तो हमने आंसर्स तो सुने जो एक्सपर्ट्स ने दिए, लेकिन वो क्वेश्चन जो पार्टिसिपेंट ने पूछा वो हम नहीं सुन पाए. सो दैट वाज वन ऑफ द प्रॉब्लम. And for some demonstrators, they were new to the tablet input output device and it caused a few problems. Other than that, this was excellent and we got a good chance to learn from that. Now I pass over control to another participant.
But as far as your question number one is concerned, you were not able to listen to the questions.
Hello.
From the video.
Good afternoon to everybody.
What we can do is we can, from the upcoming sessions, we can suggest the speakers to, repeat the question or the other remote settings.
Yes, sir, that would be really good.
Definitely we will do, sir. Please give the feedback from the
Good afternoon to everybody. Myself, Parvinder Singh, lecturer in Government Polytechnic College, Shri Ganganagar, and also a research scholar in IIT Jodhpur. And it is a very interesting and useful session in respect of both fundamentals and research areas in wireless technology. But my suggestion to all speakers, please add some video research articles and animations in each slide, and also use the white background in each slide so it will be good visible at remote centers. In last, I want to share my experience in wireless sensor networks. We have designed a low-cost patient monitoring device as a project of WHO named as Asa Syogni in 2012. You can see the article related to this research work at IEEE. It will be very useful for research workers. Thank you to all.
Hello, sir. This is Sir Trunda also from Tamil Nadu. Sir, can you hear me?
Yes, sir. We can hear you.
Sir, is there any possible to conduct any 15 days refresher course or any minimum 10 days courses?
Yes, sir. We are going to conduct such type of courses for 2 weeks. For offline will be uploaded on the website in the next few days.
Okay, sir. Thank you.
MMC Mulana, Dr. Kuldeep Pava is there. MMC Mulana, I think he has joined with us. Dr. Kuldeep Pava. MMC Mulana, Dr. Kuldeep Pava. MMC Mulana. MMC Mulana.
Hello.
You are audible, sir.
Hello, good afternoon, sir. Dr. Kuldeep Pava here.
Yes, sir.
Sir, your lectures were very informative and the course was well engaged and the objectives are very clear. But the problem in the last year is that we are not getting the network as good as in the earlier days. Right? Else everything is okay. So I congratulate you for such a good course, and we hope that in future we will also get some good course about the wireless network.
Thank you, sir. We will try to improve the quality of our connection, the remote center in future, sir. Thank you for the suggestion, sir. Moving to the JSS Academy. JSS Academy Noida. Okay, so finally, taking the feedback from the participant at NIEEE of Chandigarh. Any suggestion from your side? Thank you, sir. Thank you for session. Ma'am, do you have any solution? Thank you, ma'am. So, coming on to the end of this 5 days course on STC on wireless network. So, we wind up here. Our co-plan will be available on the website. So, for future courses, you can visit our website and see what are the various upcoming courses. You can come here to attend the courses in contact mode. That will be more beneficial because the facilities that is available here. On the website. If you have any suggestion or right?
Thank you all the remote centers for connecting with us. Soon in the upcoming STCs.
Coordinators are please requested the required information that has mailed yesterday also. He sent all the documents like bills, list of attendance, and other documents. It should reach us by the 30th.